There's a conversation happening right now in every office, every freelance workspace, and every corporate boardroom across the world. It's a conversation filled with anxiety, uncertainty, and a fundamental misunderstanding of what's actually changing. People are asking the wrong question. They're asking, will AI take my job? When they should be asking, which parts of my job will AI handle? And what does that mean for the parts that remain? Because here's what most people miss. Artificial intelligence isn't coming for professionals. It's coming for tasks. And that distinction isn't just semantic wordplay. It's the difference between obsolescence and evolution. It's the difference between fighting a tide you can't stop and learning to navigate waters that could carry you further than you've ever gone before. Think about what happened with spreadsheets. When Excel transformed business in the late 80s and early 90s, it didn't eliminate accountants. It eliminated certain accounting tasks, the manual calculation, the endless columns of handwritten numbers, the hours spent reconciling figures with a calculator and patience. What happened to accountants? They became more valuable. They moved from calculation to analysis, from bookkeeping to strategic financial planning. The professionals who understood what spreadsheets could do, who learned to leverage that power, they didn't just survive, they thrived. We're standing at a similar inflection point right now with AI, except this transformation is happening faster, touching more industries simultaneously, and the stakes are higher than they've ever been. So before you click away, before you dismiss this as another think piece about technology, before you go about your day, I want you to stay with me for the next 60 seconds. Because what I'm about to share isn't theoretical. It isn't speculation. These are patterns emerging right now, documented across thousands of companies, affecting millions of professionals, and they're probably already touching your work, whether you realize it or not. And if you find value in what we explore today, if this changes how you think about your career, your skills, or your future, hit that subscribe button. Not because I'm asking, but because understanding this shift might be one of the most important professional development decisions you make this year. And that like button? It tells the algorithm that this conversation matters, that more people need to hear it. Now, let's talk about what's really happening. The fundamental shift we're experiencing isn't about machines becoming smart enough to replace human judgment. It's about machines becoming capable enough to handle specific, defined tasks within complex professional workflows. And here's where it gets interesting. The tasks being automated first aren't always the ones you'd expect. Consider a marketing manager's typical day. There's strategy work, understanding the market, defining positioning, making creative decisions about campaigns. There's execution work, writing copy, designing assets, scheduling posts. There's analysis work, reviewing performance data, drawing insights, adjusting tactics. And there's coordination work, meetings, emails, updating stakeholders. Traditional thinking suggests AI would handle the simple stuff first and work its way up. But that's not what's happening. AI is actually quite good at certain complex tasks, like generating sophisticated marketing copy or analyzing large datasets for patterns. Meanwhile, it struggles with things humans find trivial, like understanding the unspoken context in a quick hallway conversation. The result? Jobs aren't disappearing. They're being fundamentally restructured. That marketing manager isn't unemployed, but her day looks completely different. AI generates first draft copy in seconds. It analyzes campaign performance across dozens of variables instantly. It even suggests optimal posting times and audience segments. What's left for the human? The parts that require judgment, context, relationship understanding, and creative direction. The parts that require knowing when the AI's suggestion is brilliant and when it's completely missing the point. This is where we separate the professionals who will flourish in the next decade from those who will struggle. And it has nothing to do with technical ability in the traditional sense. You don't need to become a programmer. You don't need a computer science degree. What you need is something much more fundamental. You need to understand workflows. Let me explain what I mean by that. A workflow isn't just a sequence of tasks. It's a system of dependencies, decision points, feedback loops, and quality checks. It's understanding that task B depends on task A, but only if condition C is met, and the output quality needs to be verified against standard D before moving to task E. Most professionals execute these workflows unconsciously. They've internalized them through experience. They know the steps, but they've never had to articulate why the steps exist in that particular order. AI forces that articulation. Because to leverage AI effectively, you need to understand your workflow well enough to identify which components can be automated, which require human judgment, and where the handoffs should occur. You need to see your work as a system, not just as a job. This is why generalists are struggling. Not because they lack skills, but because they lack specificity. When you describe yourself as good with people or a creative thinker, you're describing attributes, not processes. AI doesn't care about your attributes. It cares about tasks it can execute. The professional who says, "I conduct customer research through structured interviews, synthesize findings into insight categories, and translate those insights into product feature recommendations," that person can immediately identify where AI fits. Transcription? Automated. Initial categorization of common themes? Automated. The structured interview itself, with its subtle reading of emotional responses and adaptive questioning? Human. The final judgment on which insights warrant product investment? Human. See the difference? It's not about being technical. It's about being precise about what you actually do. This precision creates a fascinating paradox. As AI handles more tasks, the humans in the loop become more specialized and more valuable simultaneously. A graphic designer who used to spend 40% of their time on routine asset resizing and format conversion can now spend that time on creative conceptualization. But here's the key. They're not just doing more creative work. They're doing more valuable creative work because AI has raised the baseline quality floor. A mediocre designer who relied on technical execution skill is in trouble. A strong designer who understands visual communication principles and can direct AI tools to execute their vision, they just multiply their output capacity by 10. This multiplication effect appears across every field. Writers who understand narrative structure and audience psychology can produce more content faster, with AI handling first drafts and research compilation. But writers who are already struggling with unclear thinking and poor structure, AI just makes their weaknesses more obvious, more quickly. Software developers who understand architecture and system design can use AI code generation to build faster. But developers who were already copy-pasting from Stack Overflow without understanding the underlying logic, they're not actually gaining capability. They're just copy-pasting from ChatGPT instead. The pattern is consistent. AI amplifies capability for those who have clear understanding and judgment. It exposes weakness for those who are getting by on execution without comprehension. This brings us to the uncomfortable truth that many professional development experts won't tell you. The question isn't whether you can use AI tools. Almost anyone can type a prompt into ChatGPT. The question is whether you understand your work deeply enough to use AI strategically rather than as a crutch. Strategic AI use means knowing which tasks to automate, which to augment, and which to keep entirely human. It means understanding when AI's speed advantage matters and when careful human deliberation is worth the time cost. It means recognizing that AI excels at patterns and struggles with exceptions. So you need to know which parts of your work are pattern-based and which are exception handling. This kind of strategic thinking doesn't come from a weekend workshop on prompt engineering. It comes from deep professional knowledge combined with a willingness to deconstruct and examine your own work processes. It requires intellectual honesty about which parts of your job are truly unique and which parts are, frankly, following patterns that an AI could learn. That honesty is hard. It's much easier to believe that everything you do is creative, unique, and irreplaceable. But the professionals who are thriving in AI-integrated workflows aren't the ones clinging to that belief. They're the ones who looked at their work, identified the 20% that's truly differentiated and valuable, and enthusiastically automated the 80% that was necessary but not distinctive. Here's what that looks like in practice. A financial analyst at a mid-sized investment firm used to spend 3 days each quarter pulling data from various sources, cleaning it, formatting it, and building standardized reports. Then a day analyzing the data. Then a day preparing presentations for leadership. The analysis and strategic recommendations, that's where her real value lived. But it was only 20% of her time. She spent 2 months breaking down her workflow, learning which data pulls could be scripted, which formatting tasks could be templated, and which AI tools could generate first-draft commentary on standard financial metrics. Now those 3 days of preparation take 4 hours of oversight. She's doing 5 times as much analysis. Her recommendations are better because she has more time to think deeply, and she's being promoted because she's delivering strategic value her peers can't match. That's the new professional reality. AI doesn't replace the analyst. It replaces the data compilation. The analyst who understands this becomes more valuable. The analyst who resists this becomes redundant, not because AI took their job, but because another human, augmented by AI, can do their job better. This is why the AI is taking our jobs narrative is both right and wrong. Yes, if you define your job as a collection of tasks, and those tasks can be automated, then AI is taking that job. But if you define your professional value as your judgment, your contextual understanding, your relationship skills, and your strategic thinking, all augmented by AI tools handling the execution, then AI is making your job more valuable, not less. The dividing line is knowledge. Not knowledge of AI, but knowledge of your domain combined with awareness of AI's capabilities. You need to know your field well enough to judge AI output. You need to understand your workflows well enough to integrate AI strategically. You need to grasp your industry's dynamics well enough to anticipate where AI integration will create new opportunities and where it will eliminate old ones. This is already creating a new tier of professional differentiation. In any given field, there are now 3 categories emerging. First, the professionals being displaced. Those whose primary value was task execution that AI now handles better. Second, the professionals maintaining their position. Those adapting AI tools to do their existing work more efficiently. And third, the professionals ascending. those leveraging AI to do work that was previously impossible or impractical, creating new forms of value that didn't exist before. That third category is where the real opportunity lives. Because AI isn't just about doing existing tasks faster. It's about making entirely new workflows possible. A solo consultant can now deliver enterprise-level analysis by using AI to process data sets that would have required a team. A small business owner can launch in markets that would have required extensive research budgets by using AI for market analysis and customer insight. A creative professional can explore hundreds of concept variations in the time it used to take to develop 3. These aren't hypotheticals. These are patterns emerging right now, creating advantages for early adopters that compound over time. The consultant who builds AI-augmented analysis capabilities this year has a 2-year head start on competitors who wait. The advantage isn't linear, it's exponential, because they're learning faster, serving clients better, and building capabilities their peers won't match for years. But, and this is crucial, none of this happens automatically. Simply having access to AI tools doesn't create value. Using them poorly creates negative value by wasting time and producing low-quality output that damages your reputation. The difference between value creation and value destruction is understanding. Understanding your work, understanding AI's capabilities and limitations, and understanding how to bridge the two. That bridge is what the rest of this exploration is about. How do professionals actually use AI effectively? Not in theory, not in marketing demonstrations, but in daily practice. What does prompt engineering really mean beyond basic ChatGPT interactions? How do you connect AI capabilities with actual workflows to create compound productivity improvements? How do you develop judgment about when to trust AI output and when to override it? These aren't simple questions, and they don't have universal answers. But they have patterns, principles, approaches that work across domains and adapt to specific contexts. And understanding those patterns is the difference between being disrupted by AI and being empowered by it. The professionals who thrive in the next decade won't be the ones with the most technical skills. They'll be the ones who understand their work well enough to direct AI effectively. They'll be the ones who see AI not as a threat or a magic solution, but as a powerful tool that requires skilled operation. They'll be the ones who recognize that human judgment hasn't become less valuable. It's become more valuable because now it operates at a scale and speed that was previously impossible. This is the reality of AI in the workplace, not science fiction, not apocalyptic job losses, not utopian automation, just a fundamental shift in what humans do and how we do it. A shift that rewards clarity of thinking, depth of knowledge, and willingness to continuously adapt. A shift that's already here, already reshaping every industry, and already creating winners and losers based not on who has AI access, but on who understands how to use it strategically. There's a moment most professionals experience with AI tools. You've heard about ChatGPT, maybe you've played with it a few times, and you type in a question. Write a marketing email for my product. It gives you something. It's fine, generic, not quite right. You try again, adding more details. Better, but still not quite what you need. After 15 minutes of back and forth, you think, this is taking longer than just writing it myself. And you close the tab, convinced that AI is overhyped. Here's what just happened. You encountered the gap between casual AI use and professional AI integration. And that gap isn't about the technology being limited. It's about prompt engineering being a genuine skill, not a parlor trick. Most people think prompt engineering means knowing the right phrases to type into ChatGPT. Like there's a secret language, a set of magic words that unlock AI's full potential. That's not what prompt engineering is. Prompt engineering is structured thinking made explicit. It's taking the implicit knowledge and context you carry in your head and translating it into instructions that an AI can act on. And that translation requires something most people rarely practice: extreme clarity about what you actually want. Let's start with why this matters. AI models, whether we're talking about GPT, Claude, or any other large language model, don't understand your work the way a colleague does. They don't have your industry context, your company's brand voice, your project's constraints, or your personal standards. Every time you prompt an AI, you're essentially hiring a hyper-competent but completely inexperienced contractor who can do amazing work if given clear direction, but will produce garbage if you're vague. The difference between effective and ineffective prompting isn't about knowing secret commands. It's about understanding what information the AI needs to give you what you want. And that's why prompt engineering starts with task decomposition, breaking down what you're trying to achieve into its component parts. Consider that marketing email example. Write a marketing email for my product is a task, but it's not a decomposed task. What's missing? The audience, the goal, the tone, the key message, the constraints, the format. A professional prompt engineer doesn't start with the AI. They start with their own clarity. They ask themselves, what's this email actually supposed to do? Who's receiving it? What do they already know? What action do I want them to take? What's the competitive context? What's our differentiation? What's our brand voice? Once you have those answers, your prompt becomes specific. Write a 150-word email to enterprise software buyers who have downloaded our white paper but haven't scheduled a demo. The goal is to create urgency around scheduling without being pushy. Emphasize our integration capabilities, which our research shows is their top concern. Use a consultative, expert tone. Think trusted advisor, not salesperson. Include one specific client success metric and a clear call to action with a Calendly link. Notice what happened there. You moved from a generic request to a structured brief. And here's the key insight. That structured brief isn't just helpful for the AI. It forces you to think clearly about what you're actually trying to achieve. Professionals who excel at prompt engineering aren't just good at talking to AI. They're good at clarifying their own thinking. The prompt engineering skill and the strategic thinking skill are actually the same skill applied in different contexts. This clarity compounds, because once you've crafted a good prompt, you're not done. Professional prompt engineering is iterative. You get output, you evaluate it, you refine your prompt based on what worked and what didn't. This isn't trial and error, it's systematic improvement. You're learning what aspects of your instructions the AI responds to, what details matter, and what's just noise. Let me show you what this looks like in practice. A content strategist working for a B2B SaaS company needs to produce weekly blog posts. Her first attempt at using AI. Write a blog post about project management software. The result is generic SEO bait that could have been written by anyone about any tool. Her second attempt includes context layering. Context layering means providing the AI with background information that shapes its output. You are a content strategist for a project management tool aimed at distributed marketing teams. Our differentiator is real-time collaboration features. Our audience is marketing directors at companies with 50 to 200 employees who are currently using a mix of email, spreadsheets, and basic PM tools. They're frustrated with lack of visibility and excessive meeting time. Write a 1,200-word blog post that positions project management software not as a task tracker, but as a communication reducer. Include a section on the hidden cost of coordination overhead. See the difference? She's not just asking for content. She's providing the strategic context that makes the content valuable. And this is where prompt engineering becomes powerful. You're not replacing your expertise. You're channeling it through AI to accelerate execution. But context layering alone isn't enough. Professional prompt engineering also uses constraints strategically. Constraints aren't limitations, they're clarity tools. When you tell the AI, use only simple sentences under 20 words, or avoid jargon and buzzwords, or include exactly 3 concrete examples, you're not restricting creativity. You're preventing the AI from filling space with generic fluff. Here's why this matters. AI models are trained on vast amounts of text from the internet, which means they're very good at producing text that sounds like internet text. But most internet text is mediocre. It's verbose, generic, and filled with filler phrases. Without constraints, AI will default to that style. With thoughtful constraints, you push it toward conciseness, specificity, and usefulness. A software developer using AI for code generation discovered this principle through frustration. His initial prompts produced working code that was bloated, poorly commented, and hard to maintain. His refined approach: write a Python function that processes user input validation, maximum 30 lines. Include type hints, add docstring with parameter descriptions and edge cases. Prefer explicit logic over clever shortcuts. Handle the edge case where input is none separately from where input is invalid format. The result? Code that didn't just work, but code that was maintainable, readable, and aligned with his team's standards. He wasn't saving time by replacing his coding skill. He was saving time by having AI handle the mechanical typing while he focused on architecture and logic. This pattern repeats across domains. A graphic designer uses AI image generation not by typing "create a logo," but by providing detailed specifications about color psychology, geometric balance, negative space, and brand personality. An attorney uses AI for document drafting not by asking for a contract, but by specifying jurisdiction, governing law, specific clauses needed, and risk allocation principles. A financial analyst uses AI for report generation not with "analyze this data," but with detailed instructions about which metrics matter, what comparisons to draw, and what threshold changes are significant. In every case, the professional isn't being replaced by AI. They're using AI as a capable assistant that requires detailed instruction. And here's where it gets interesting. The ability to give detailed instruction requires deep professional knowledge. You can't specify what matters in a legal contract unless you understand contract law. You can't direct meaningful financial analysis unless you understand what drives business value. You can't guide effective design generation unless you understand design principles. This is the counterintuitive reality of AI tools. They're most valuable to experts, not novices. Novices lack the knowledge to prompt effectively or evaluate output quality. Experts can leverage AI to multiply their capabilities because they know what to ask for and can judge what they get. But expertise alone isn't sufficient. You also need to understand AI's actual capabilities and limitations, not the mythologized version. AI is excellent at pattern recognition and variation generation. It's excellent at synthesizing information from diverse sources. It's excellent at maintaining consistent style and tone across large volumes of content. It's terrible at genuine creativity, the kind that makes novel connections humans haven't made before. It's terrible at factual accuracy without verification. It's terrible at understanding unstated context and implication. Professional prompt engineering accounts for these limitations. You don't ask AI to be creative in ways it can't be. Instead, you ask it to generate variations on themes you provide. Then you select and refine. You don't trust AI's factual claims without verification. Instead, you use it to draft and structure, then you fact-check. You don't assume AI understands your context. Instead, you make context explicit, even when it seems obvious to you. This leads to one of the most important practices in professional prompt engineering: verification loops. A verification loop is a systematic approach to checking AI output before using it. For factual content, that means checking claims against reliable sources. For code, it means testing thoroughly before deployment. For strategic content, it means reviewing against business goals and brand standards. For creative work, it means evaluating against aesthetic principles and audience appropriateness. Verification loops aren't about distrusting AI. They're about using AI appropriately within a quality-controlled workflow. Think of it like using spell check. Extremely useful, but you still need to read what you've written because spell check catches typos, but not logic errors or wrong word usage. AI is spell check for entire work processes. Powerful, but requiring human judgment in the loop. This human-in-the-loop approach is what separates professional AI integration from amateur experimentation. Amateurs try to use AI as a black box. Put something in, get something out, use it directly. Professionals use AI as one component in a workflow. Put something in, get something out, evaluate it, refine it, verify it, and then use it. The workflow matters more than the tool. Speed is the advantage everyone talks about with AI. Do in minutes what used to take hours is the promise splashed across every product launch and conference keynote. But here's what they're not telling you. Speed only matters if you're doing the right things. And more importantly, speed compounds when you connect AI to actual workflows, not just when you use it as a standalone tool. Think about how most people use AI right now. They open ChatGPT, they type a prompt, they get a response, they copy it somewhere, they use it, then they close ChatGPT. The next day, they repeat the process from scratch. There's no memory, no consistency, no integration with their other tools. They're treating AI like a very smart notepad, not like a component in a system. Professional automation is completely different. It's about connecting AI capabilities to the software tools you already use, creating workflows where information flows automatically, and building systems that improve the quality and speed of your work without requiring constant manual intervention. This isn't about replacing your job with robots. It's about eliminating the repetitive, low-value parts so you can focus on the high-value parts that require your judgment and expertise. Let's start with a realistic example. A customer success manager at a software company spends significant time each week reading customer support tickets, identifying patterns, and flagging issues that need escalation. Before AI, this was entirely manual. She'd scan through hundreds of tickets, make notes, categorize issues, and prepare a weekly summary for the product team. Her first AI improvement was simple. She started using ChatGPT to help categorize tickets. She'd copy-paste a ticket, ask for categorization, get a response, record it. This saved some time, but not much. She was still doing everything manually, just with AI assistance for one small part. Her second improvement was actual workflow automation. She connected her ticketing system to a script that automatically extracted new tickets each day, sent them to an AI API for initial categorization and sentiment analysis, compiled the results into a structured database, and generated a daily summary. Now she spends 5 minutes reviewing the automated summary instead of 2 hours reading raw tickets. And the pattern recognition is better because the AI is consistently analyzing every ticket, not just the sample she had time to review. This is what workflow automation with AI looks like. Taking a repetitive process, identifying which steps can be automated, and building systems that handle those steps consistently without your constant input. But here's the critical part. She didn't eliminate her role. She elevated it. She's not categorizing tickets anymore. She's reviewing patterns, making strategic decisions about which issues matter most, and collaborating with the product team on solutions. The automation freed her to do more valuable work, and the quality of her insights improved because she's working from complete data, not a sample. This pattern, automate the repetitive, elevate the strategic, appears everywhere once you start looking for it. A marketing team that manually created social media posts for each platform now uses AI to generate platform-specific variations from a single piece of content. Then they review and approve the set. A legal team that manually formatted discovery documents now has scripts that standardize formatting automatically, so attorneys can focus on review and strategy. An operations team that manually compiled inventory reports now has automated data pulls and AI-generated summaries, so they can focus on optimization decisions. In each case, the professionals involved needed to understand 3 things: their workflow, AI capabilities, and how to connect them. That connection is where most people get stuck. They know their work. They know AI can theoretically help, but they don't know how to build the bridge between the two. The bridge comes in 3 forms: scripts, no-code platforms, and integrated software with AI features. Each has different use cases and requires different skill levels to implement. Scripts are for people comfortable with basic programming or willing to learn. Python is the most common language for this, and you don't need to be a software engineer to write useful automation scripts. A researcher who learned basic Python can now automatically extract data from PDFs, clean it, run initial statistical analysis, and generate first draft visualizations. Work that used to take her 2 full days now takes 20 minutes of script runtime while she works on other things. The script itself isn't complex. It's maybe 50 lines of code that uses existing libraries for PDF processing, data manipulation, and visualization. What makes it valuable isn't technical sophistication. It's understanding the workflow well enough to automate it. She knew what data she needed, what format it should be in, what analysis mattered, and what questions the visualizations needed to answer. The code is just the implementation of that understanding. No-code platforms are for people who want automation without programming. Tools like Zapier, Make, or N8N let you connect different software services and create workflows visually. An e-commerce business owner uses this approach to connect her store, inventory system, email platform, and AI tools. When a customer makes a purchase, the system automatically updates inventory, generates a personalized thank you email using AI, schedules a follow-up survey, and adds the customer to appropriate marketing segments. No coding required, just visual workflow building and configuration. The limitation of no-code tools isn't capability, they're remarkably powerful. It's that they only work with services that have existing integrations. If your specific software isn't supported, you're stuck, unless you can use their API connectors, which requires some technical knowledge. But for common business tools, no-code platforms offer enormous automation potential with minimal technical barrier. The third approach, using software with built-in AI features, is the easiest to start with, but often the least flexible. Many professional tools now include AI capabilities directly. Writing software with AI editing, design tools with AI generation, development environments with AI code completion. These are valuable and require zero setup, but they're also constrained by what the software maker decided to include. You're using AI how they think you should, not necessarily how your specific workflow requires. The most effective professionals combine all three approaches. They use built-in AI features for common tasks, no-code platforms for connecting different tools, and custom scripts for specialized needs their workflow has. This isn't about being a technical genius. It's about being strategic about where to invest effort in automation. Here's how to think about that investment. Any task you do more than once a week is worth considering for automation. Any task that follows consistent rules is a good automation candidate. Any task where speed and consistency matter more than creativity is where automation excels. And any task where you're mostly copying information from one place to another is practically begging for automation. But, and this is crucial, not every task should be automated. Human judgment tasks shouldn't be automated. Relationship-building tasks shouldn't be automated. Creative strategy tasks shouldn't be automated. The goal isn't to automate everything. It's to automate the low-value repetitive work so you have more time for high-value judgment work. This is why workflow analysis is so important before you start automating. Map out your actual work process. Where does information come from? Where does it go? What decisions do you make? What's mechanical versus what requires judgment? What takes the most time? What's most error-prone? These questions reveal automation opportunities that actually matter. A content creator did this analysis and realized she spent 6 hours a week on tasks that were pure execution. Resizing images for different platforms, formatting posts to match each platform's requirements, scheduling publications, and tracking engagement metrics. All necessary, none requiring creative judgment. She built a system using AI and no-code tools that handles all of this automatically. She creates the core content, and the system handles adaptation and distribution. Those 6 hours are now spent on strategy, community engagement, and content quality improvement. The result isn't just time savings, it's quality improvement. Her content performs better because she has more time to make it good. Her community engagement is stronger because she's not exhausted from manual platform management. And she's testing new content formats because she has capacity for experimentation. This is the real value of workflow automation with AI. It doesn't just save time, it changes what's possible. Tasks that were too time-consuming to do thoroughly become manageable. Analysis that required a team becomes feasible for an individual. Quality standards that were aspirational become standard practice. But And this might be the most important point in this entire chapter. Automation creates new responsibilities. When you automate, you become responsible for monitoring the automation, maintaining it, and ensuring its output quality. This is often overlooked by people excited about AI possibilities. They automate something, it works great for a month, then it breaks or starts producing poor results, and they don't notice until there's a problem. Professional automation includes monitoring and maintenance systems. That content creator who automated her distribution? She has a weekly review process where she checks that everything published correctly, engagement metrics are tracking properly, and image quality is maintained. It takes her 30 minutes a week instead of the 6 hours the tasks used to require. But that 30 minutes is non-negotiable. Automation without monitoring is how you accidentally send broken links to your entire mailing list or publish incorrectly formatted content. This monitoring requirement is actually a benefit in disguise. It forces you to think about quality metrics and success criteria. What does good output look like? How do you know when something's wrong? What checks catch problems before they impact your work? These questions improve not just your automation, but your understanding of quality in your work generally. There's a resume trend that's been growing for the past decade, accelerating rapidly in recent years. Professionals list 15, 20, sometimes 30 different software tools under their skills section. Photoshop, Illustrator, Figma, Sketch, InDesign, After Effects, Premiere, DaVinci Resolve, Blender, Cinema 4D, and on and on. The implicit message is clear. Versatility equals value. The more tools you know, the more hireable you are. The more marketable. The more prepared for whatever the job throws at you. Here's the uncomfortable truth that most career advice won't tell you. This approach is creating a generation of professionals who are functionally mediocre at everything. They can open many programs. They can find basic functions. They can follow tutorials for simple tasks. But they can't do anything exceptional. They can't solve complex problems. They can't push tools to their limits. They can't create work that makes people stop and think, how did they do that? And in an AI-saturated marketplace, being mediocre at many things is the most dangerous position you can occupy, because AI is also mediocre at many things. You're competing directly with technology that can generate passable work across multiple domains. You're a generalist competing with a generalist that works for pennies and never sleeps. The professionals thriving right now, the ones commanding premium rates, getting headhunted, building reputations that AI can't touch, they're doing something different. They're going deep instead of wide. They're mastering one professional tool so thoroughly that they can do things with it that most people don't even know are possible. And that depth creates a moat that AI can't easily cross. Let me show you what mastery actually looks like, because it's not what most people imagine. A 3D artist specializing in Blender isn't just someone who knows how to model objects and apply materials. That's beginner level. Intermediate level is understanding lighting, composition, topology, and efficient workflow. Mastery is something else entirely. A Blender master understands the software's architecture. They know how geometry nodes work at a mathematical level. They can write custom shaders. They understand how Blender's rendering engine differs from others and why that matters for specific use cases. They can optimize scenes that would crash on most machines. They can troubleshoot problems that would stump 99% of users. They can look at a rendering and tell you exactly which settings were used to create it. This isn't theoretical knowledge. It's practical expertise that manifests in capability. Give a master and a competent user the same project, and the master will deliver something better, faster, and with fewer technical issues. Not because they work harder, but because their depth of knowledge lets them work smarter. They know which approaches will create problems down the line. They know shortcuts that aren't in tutorials. They know how to achieve effects efficiently that others achieve through brute force, if they can achieve them at all. This depth creates multiple forms of value that are largely immune to AI disruption. First, problem-solving ability. Every professional tool has moments where things go wrong. Files corrupt. Features behave unexpectedly. Results don't match expectations. A surface-level user gets stuck. They don't understand the tool well enough to diagnose the problem, so they restart, redo work, or give up. A master debugs efficiently because they understand what's happening underneath the interface. They don't just know which button to click. They know why that button exists and what it actually does to the underlying data. Second, efficiency at scale. When you master a tool, you develop workflows that compound over time. You know exactly which features to use for which situations. You've customized your workspace, built templates, created presets, and learned keyboard shortcuts that aren't even documented. A task that takes someone else 2 hours takes you 20 minutes, not because you rush, but because you've optimized every step through deep familiarity. And that efficiency advantage multiplies across hundreds of tasks over a career. Third, pushing boundaries. Every professional tool has an official capability range, what it's designed to do, what the tutorials cover, what the documentation explains. Masters operate beyond that range. They combine features in ways the developers didn't anticipate. They understand the tool well enough to bend it to purposes it wasn't designed for. This is where genuinely innovative work comes from. Not from switching between tools, but from pushing a single tool to its absolute limits. Fourth, and perhaps most important, judgment. When you master a tool, you develop intuition about what's possible, what's practical, and what's optimal. A client asks, "Can we create this effect?" A beginner isn't sure. An intermediate user can figure it out but doesn't know if it's the right approach. A master knows immediately whether it's possible, how long it will take, whether it's the best solution, and what alternatives might work better. That judgment is incredibly valuable because it prevents wasted effort and guides projects towards success from the beginning. This value proposition is resistant to AI for fundamental reasons. AI can generate competent work using tools. What AI cannot do is deeply understand a tool's architecture, develop intuition about edge cases, troubleshoot novel problems, or push beyond documented capabilities. AI operates within parameters. Masters expand parameters. AI follows patterns. Masters create new patterns. Now, here's where people get this wrong. They hear master one tool and think it means ignoring everything else. That's not what depth means. Depth means having one primary tool you know exceptionally well. With complementary tools, you understand adequately. A Photoshop master probably also knows Lightroom reasonably well, because they serve connected purposes. An Excel master probably has working knowledge of Python for cases where spreadsheets become impractical. A developer who's mastered VS Code probably understands terminal environments and Git workflows. But there's a hierarchy. One tool is where your expertise lives. Other tools are support systems. And that hierarchy matters Because mastery requires time and practice that you cannot divide infinitely. There are only so many hours in a career. Spreading those hours across 15 tools means shallow knowledge of all of them. Concentrating those hours on one tool with adequate knowledge of a few others means deep expertise where it matters. The question then is which tool to master? And the answer isn't universal. It depends on your field, your interests, and market demand. But there are principles that guide the decision. First, choose tools with depth. Some software is intentionally simple, designed for ease of use with limited advanced features. These are poor mastery candidates because there's not enough there to master. You want tools that professionals in your field have been using for decades, that have extensive advanced features, that have communities of experts pushing boundaries. Excel, Photoshop, Blender, Maya, AutoCAD, specialized IDEs. These are tools with sufficient depth to support genuine mastery. Second, choose tools with staying power. Technology changes, software gets replaced, new tools emerge. But some tools have proven remarkably durable. Excel has been the spreadsheet standard for 35 years. Photoshop has dominated image editing for even longer. These tools evolve, but the core knowledge remains relevant. Learning a brand new, trendy tool with no established user base is risky. It might be replaced before you achieve mastery. Learning a tool with a 20-year track record is a safer investment. Third, choose tools that align with valuable work. This should be obvious, but often isn't. Mastery without market value is just a hobby. Make sure the tool you're mastering is central to work that people pay for. A tool used daily by professionals earning good incomes is worth mastering. A tool used occasionally for minor tasks is not, even if it's interesting. Fourth, choose tools you actually enjoy using. Mastery requires thousands of hours of practice. If you hate the tool, you won't put in the hours. If you enjoy it, the learning feels less like work and more like exploration. This isn't about following your passion naively. It's recognizing that sustained expertise requires sustained engagement. And sustained engagement is much easier when you like what you're doing. Once you've chosen your tool, the path to mastery is fairly consistent across domains. It starts with fundamentals, not skipping basics, not jumping to advanced tutorials, but truly understanding core concepts. A photographer learning Photoshop needs to understand layers, not just that they exist, but what they actually are and how they work. A financial analyst learning Excel needs to understand cell references, not just typing them, but what absolute versus relative references mean, and when each is appropriate. This foundation phase feels slow. It's tempting to skip ahead to impressive techniques. Don't. Every impressive technique builds on fundamentals, and if your foundation is shaky, your advanced work will be fragile. Masters revisit fundamentals regularly, not because they've forgotten them, but because deeper understanding of basics improves everything built on top. After fundamentals comes deliberate practice. This is different from just using the tool. Deliberate practice means working at the edge of your current capability, tackling projects slightly beyond your comfort zone, focusing on specific weaknesses, and analyzing your results critically. A 3D modeler might spend a week just practicing topology on complex organic shapes. A data analyst might work through every statistical function in Excel methodically, understanding not just how to use each one, but when and why. This practice phase is where most people plateau. They reach competent enough and stop pushing. They can do their job adequately, so they see no reason to improve further. This is the gap between competent and masterful. Masters keep practicing intentionally even after they're professionally functional. They set challenges. They replicate work they admire. They explore features they don't currently need, knowing that understanding the full tool makes them better at the parts they use regularly. Alongside practice comes immersion in the community. Every professional tool has a community of users at various levels. Forums, social media groups, conference presentations, published tutorials, expert blogs. Masters engage with this community not passively, but actively. They ask questions. They help others. They study expert work and analyze techniques. They follow cutting-edge practitioners and learn from their approaches. This community engagement accelerates learning in ways that solo practice cannot. You discover techniques you wouldn't have found on your own. You see applications you wouldn't have imagined. You learn from others' mistakes without making them yourself. And crucially, you build reputation. As you help others and share knowledge, you become known in the community. That reputation becomes professional capital, job offers, client referrals, collaboration opportunities. The path to mastery also requires understanding the tool's limitations. Beginners think their tool can do everything. Intermediate users hit limitations and get frustrated. Masters know exactly what their tool can and cannot do, and they know when to use different approaches. This isn't about the tool being inadequate. It's about understanding that every tool is optimized for specific use cases and suboptimal for others. An Excel master knows when a problem should be solved in Python instead. A Photoshop master knows when to use Illustrator. This judgment comes from deep knowledge, not shallow breadth. Here's what happens when you achieve genuine mastery. Your relationship with your tool changes. It stops being a program you use and becomes an extension of your thinking. You're no longer consciously thinking, I need to do X, so I'll use feature Y. You're thinking about the outcome you want, and your hands are executing without conscious attention to the technical steps. This is fluency. It's what separates people doing work from people creating work. And this fluency is visible in the results. Two people can use the same software, work on the same project with the same time allocation, and produce dramatically different quality. The difference is mastery. The master's work is cleaner, more sophisticated, more polished, more innovative. Not because they tried harder, but because their depth of knowledge enables things that surface knowledge doesn't. In an AI-integrated workplace, this distinction becomes even more important. AI can use tools at a competent level. It can follow standard procedures, apply common techniques, and produce adequate results. What AI cannot do is operate with the fluency, judgment, and innovation that comes from mastery. When you've mastered a tool, you're not just using it, you're thinking through it. That cognitive integration is fundamentally different from execution capability, and it's what keeps humans valuable in professional contexts. This is why the career advice about learning as many tools as possible is so misguided. It optimizes for appearing versatile on a resume while undermining the depth that creates actual value. Employers might be impressed by a list of 20 software tools in a job application, but once you're hired, what matters is whether you can solve real problems, produce excellent work, and handle situations that aren't in the manual. And those capabilities come from depth, not breadth. If you take one thing from this chapter, let it be this. In a world where AI can do many things adequately, human value increasingly comes from doing specific things exceptionally. And exceptional performance requires mastery, not familiarity, not competence, mastery. The kind that takes years to develop, that can't be replicated by watching tutorials, that can't be matched by AI, and that becomes a foundation for a career that AI enhances rather than threatens. So identify your tool, the one that matters most in your field, the one you use constantly or aspire to use professionally. And instead of learning 5 new tools this year, spend that time and energy going deeper into the one that matters. Learn its architecture, master its advanced features, join its community, push its boundaries, build fluency that becomes second nature. That depth is your moat. That's your professional security in an AI-saturated market. Not because you're avoiding AI. You should absolutely use AI to enhance your work, but because you're building capability that AI cannot easily replicate. You're becoming not just a tool user, but a true expert whose judgment, innovation, and fluency create value that no algorithm can match at any price. And if you're finding value in this exploration of how professionals actually succeed in an AI-integrated workplace, if this is changing how you think about your skills, your career development, your professional strategy, do me a favor. Hit that subscribe button because we're building a community of people who aren't just adapting to AI, but strategically positioning themselves to thrive because of it. And that like button? It helps more people find this content, which means more professionals understanding that AI isn't the threat. Lack of depth is the threat. AI is just revealing what was always true. Mastery matters. There's a dangerous pattern emerging as AI tools become ubiquitous in professional work. Someone encounters a problem. Their code isn't running correctly. Their analysis shows unexpected results. Their design isn't rendering properly. And they immediately ask ChatGPT or Claude to fix it. The AI provides an answer. They implement it without fully understanding why it works. The immediate problem disappears, and they move on, having learned nothing. Repeat this pattern a few dozen times, and you have a professional who can get things done but doesn't actually understand what they're doing. They're functional in the same way someone following a GPS is functional. They reach their destination, but they couldn't navigate without it. The first time the GPS fails, they're lost. This is the dark side of AI-assisted work. It can make you worse at your job while making you feel more productive. And the insidious part is that this degradation happens gradually. You don't wake up one day unable to think. You just slowly stop exercising the problem-solving muscles that professional expertise requires. And those muscles atrophy without you noticing until you need them, and they're gone. But here's what most people miss. AI can be used to enhance problem-solving ability rather than replace it. The difference isn't in the tool, it's in how you use it. And that difference is everything. Let me show you what AI-assisted problem-solving looks like when done correctly, because it's fundamentally different from the outsourcing your thinking approach most people default to. A software developer is debugging a function that's producing incorrect output. The naive approach: copy the code into ChatGPT, describe the problem, implement whatever solution it suggests. The sophisticated approach: use AI as a thinking partner, not a solution provider. Here's what that looks like. First, he articulates the problem clearly, not just, "my code doesn't work," but specifically what output he expects, what output he's getting, and what he's already tried. This articulation isn't for the AI, it's for him. The process of clearly stating a problem often reveals insights about the solution. It forces precision in thinking that vague frustration doesn't require. Second, he forms hypotheses. Before asking AI anything, he thinks through what might be causing the issue. Is it a logic error? A data type mismatch? An edge case he didn't consider? He develops theories about the problem based on his understanding of how the code should work. This step is crucial because it keeps his analytical skills engaged rather than outsourcing all thinking to AI. Third, when he does consult AI, he's not asking for the answer, he's asking for perspective. I think this might be an integer overflow issue in this calculation. Can you analyze this function and tell me if that hypothesis makes sense, or if there are other potential causes I should consider? This framing is completely different from "fix my code." He's maintaining ownership of the problem while using AI to expand his analysis. The AI provides perspective. Maybe it confirms his hypothesis and suggests a specific line where the overflow occurs. Maybe it identifies a different issue he hadn't considered. Maybe it asks clarifying questions that make him realize he misunderstood the problem. In all cases, he's learning. He's not just getting a solution, he's developing better understanding of how this type of problem works. Fourth, when he implements a solution, he doesn't blindly accept AI suggestions. He evaluates them. He asks himself, why would this fix work? What principle is being applied here? Are there alternative approaches? What are the trade-offs between solutions? This evaluation phase is where learning happens. It's the difference between copying an answer and understanding a concept. Fifth, he tests not just that the fix works, but that he understands why it works. He might modify the code intentionally to see if he can predict what will happen. He might implement the same solution a different way to confirm his understanding. This experimentation cements learning in ways that just fixing the problem doesn't. This entire process uses AI, but it doesn't outsource thinking. AI is a tool in his problem-solving process, not a replacement for problem-solving skills. And the difference in outcomes is dramatic. After solving problems this way repeatedly, he's a better debugger. He recognizes patterns faster. He develops better intuition about where issues likely are. He builds mental models of how systems work that make him effective even when AI isn't available. Compare that to the developer who just pastes code into ChatGPT and implements whatever it suggests. Short-term, both developers fix their immediate problems. Long-term, one is building expertise, and the other is becoming dependent on AI for basic professional functions. One is becoming more valuable, the other is becoming more replaceable. This pattern, using AI as a thinking partner rather than a solution provider, applies across every professional domain. An analyst encounters data that doesn't match her expectations. The sophisticated approach isn't asking AI, "What's wrong with this data set?" It's systematically working through possibilities. Data collection issues, calculation errors, sampling problems, and using AI to help evaluate each hypothesis. She might ask, if this data anomaly was caused by a sampling error, what patterns would I expect to see? The AI's response helps her think through implications, not think for her. A designer's layout isn't working visually, and she can't articulate why. Rather than asking AI to redesign it, she uses AI to help analyze what's not working. I'm trying to create visual hierarchy, but something feels off. Can you identify which elements are competing for attention and explain why? The AI's analysis helps her develop her own eye for design problems. She's not outsourcing aesthetic judgment. She's using AI to articulate principles that improve her judgment. A project manager is dealing with a team conflict. He doesn't ask AI to solve the conflict. Interpersonal issues require human judgment and relationship context AI doesn't have. But he might use AI to think through dynamics. In a team where technical and business perspectives are clashing, what are typical underlying sources of tension beyond the surface disagreement? The AI's response might help him see dynamics he missed, giving him better questions to ask his team. In every case, the pattern is the same. Articulate the problem clearly. Form your own hypotheses. Use AI to expand your analysis. Evaluate AI suggestions critically, and test your understanding. This keeps your thinking skills sharp while leveraging AI's ability to provide alternative perspectives, recall relevant information, and analyze patterns at scale. This approach also addresses one of the biggest risks with AI, the confidence problem. AI tools often present information with high confidence regardless of accuracy. If you're outsourcing your thinking, you'll implement wrong answers confidently. If you're using AI as a thinking partner, your own judgment acts as a quality filter. You catch errors because you understand the domain well enough to spot when something doesn't make sense. A financial analyst using AI to help interpret economic indicators notices the AI confidently cites a statistic that seems off. Because she maintained her analytical engagement rather than blindly accepting AI output, she checks the source. The statistic is wrong. The AI hallucinated a plausible number. She corrects it and continues her analysis. If she'd been outsourcing her thinking entirely, that error would have made it into her report, damaging her credibility. This quality filter only works if you maintain domain expertise. And you only maintain domain expertise if you keep thinking through problems rather than delegating them. This is why the how you use AI matters more than whether you use AI. Used well, AI makes you smarter by expanding your analytical capacity. Used poorly, it makes you dumber by atrophying your thinking skills. There's also a strategic advantage to this approach. It makes AI failures non-catastrophic. When AI tools go down, when the service is unavailable, when you're in a context where you can't access it, professionals who use AI as a thinking partner continue functioning. They're slower, perhaps, but they're competent. Professionals who've outsourced their thinking to AI are suddenly much less capable. They've become dependent on a tool that won't always be available. This independence isn't about avoiding AI. It's about integrating it strategically. Think of it like calculators. Professionals use calculators constantly, but they understand the underlying math well enough that calculator unavailability is inconvenient, not crippling. They can estimate reasonably, check if results make sense, and do calculations manually when needed. That's the relationship you want with AI. Frequent use, strategic leverage, but retained capability when it's unavailable. Building this relationship requires intentional practice. It's easier to just ask AI for answers than to think through problems with AI as a sounding board. But the easy path is the one that erodes capability. The path that builds capability requires discipline. Always form your own analysis before asking AI. Always evaluate AI responses critically. Always verify you understand why something works, rather than just that it works. And regularly solve problems entirely without AI to ensure your skills remain sharp. One specific technique that helps: explaining AI's reasoning back to it in your own words. When AI provides an explanation or solution, rephrase it yourself and ask the AI if your understanding is correct. This forces you to process the information rather than just accepting it. It's like the teaching technique where explaining something proves you understand it, except you're explaining back to AI to confirm your comprehension. Another technique: use AI to explore alternatives even when you have a working solution. This approach solves the problem, but what are 3 different ways I could achieve the same result? This builds flexibility in thinking. You're not just solving the immediate problem, you're developing a richer mental model of the solution space. Over time, this makes you much better at problem solving because you see multiple paths rather than just one. A third technique: deliberately use AI on problems you already know how to solve. Compare your approach with AI suggestions. Sometimes AI will show you better methods. Sometimes your approach is superior. Either way, you're learning by comparison rather than substitution. This keeps your expertise sharp while still benefiting from AI's different perspective. The meta skill here is maintaining what psychologists call metacognition, thinking about your thinking. When using AI, regularly ask yourself, am I understanding this, or am I just implementing it? Could I explain this approach to someone else? Would I be able to solve a similar problem without AI? If the answers are unsatisfying, you're using AI in a way that's degrading your capability rather than enhancing it. This matters enormously for career development. Employers and clients don't just pay for problem solving, they pay for judgment. Judgment is what distinguishes adequate solutions from excellent ones. Judgment is knowing when to use which approach, what trade-offs are worth making, what risks are acceptable. And judgment develops through experience of thinking through problems, not outsourcing that thinking. AI can enhance judgment by providing more data points, more perspectives, more possibilities to evaluate. But it can only enhance judgment that exists. If you've atrophied your analytical skills by outsourcing them, AI isn't enhancing anything, it's replacing you. And the moment AI becomes commoditized enough that anyone can get the same results you can, your value disappears. This is the existential question every professional using AI needs to answer. Are you using AI to amplify your capabilities, or are you using it to compensate for capabilities you're allowing to degrade? The honest answer to that question determines whether AI is making you more valuable or more replaceable. The professionals who will thrive aren't the ones who avoid AI. That's just denying reality. They're the ones who integrate AI while maintaining and even developing their core thinking skills. They use AI to go deeper into problems, explore more alternatives, and analyze more complex scenarios than they could without it. But they're still doing the thinking. AI is the telescope that lets them see further, not the eye that does the seeing. Most professionals spend their entire careers clicking buttons without understanding what happens underneath. They know that pressing export creates a file. They know that importing that file into another program sometimes works and sometimes doesn't. When it doesn't work, they're confused. They try different settings randomly. They Google error messages. They ask coworkers. Sometimes they find a solution, but they don't understand why it works. They just know it does. This surface-level understanding is fine when everything goes smoothly. It becomes a critical vulnerability when things break, when you need to work across platforms, when you're trying to build efficient workflows, or when you need to collaborate with others. And in an AI-integrated professional environment where automation connects different tools and systems, this lack of understanding becomes a serious competitive disadvantage. Here's why. Understanding file formats and data pipelines isn't about technical trivia. It's about understanding how information moves through systems, maintains integrity across transitions, and can be manipulated effectively. This knowledge is the difference between someone who uses software and someone who controls their workflow. It's invisible until you need it, and then it's everything. Let me show you what this looks like in practice, because it's more relevant to daily work than most people realize. A marketing team creates content across multiple platforms: graphics in Photoshop, videos in Premiere, social posts in various management tools, website updates in a CMS, reports in PowerPoint. To someone without format understanding, these are just files they save and share. To someone who understands formats and pipelines, this is a data flow system with specific requirements, limitations, and optimization opportunities. The team encounters a common problem. Graphics look perfect in Photoshop, but appear washed out when posted to certain platforms. Most people treat this as a mystery. Some platforms just show colors differently, they assume, nothing to be done about it. Someone with format knowledge understands what's actually happening: color space conflicts. Photoshop might be working in RGB Adobe 1998, but web platforms expect sRGB. When the conversion happens automatically during upload, colors shift. The solution isn't mysterious once you understand the underlying issue. Export from Photoshop in sRGB color space, or convert before uploading. This example seems simple, maybe even obvious to experienced designers. But extend the principle across dozens of similar issues, and you start seeing a pattern. Most workflow problems that seem random or unsolvable are actually predictable consequences of format incompatibilities, data transformations, or pipeline limitations. Understanding these underlying systems turns confusing problems into solvable puzzles. Consider video production. A novice knows they can export video in different formats: MP4, MOV, AVI. They might know that some formats work better for certain purposes, but they don't understand what a codec is, how it differs from a container format, why some videos play everywhere while others require specific software, or why file sizes vary dramatically for seemingly identical content. A professional with format knowledge understands that MP4 is a container that can hold video encoded with various codecs: H.264, H.265, others. They know that H.265 provides better compression than H.264, but requires more processing power to decode, which matters for playback on older devices. They know that some platforms re-encode uploaded video, which means exporting at maximum quality is pointless because it'll be compressed anyway. They know that audio and video are separate streams that can be encoded independently, which explains why sometimes audio works but video doesn't, or vice versa. This knowledge isn't trivia. It's practical capability that manifests in dozens of ways. They produce smaller files that maintain quality because they understand compression trade-offs. They avoid compatibility issues because they know which formats work across platforms. They troubleshoot rendering problems efficiently because they understand what's actually happening during export. They collaborate more effectively because they can specify technical requirements clearly. The same pattern appears in every professional domain. A data analyst working with CSV files needs to understand character encoding, delimiter choices, how different programs handle line breaks, and why opening a CSV in Excel sometimes corrupts data. A 3D artist needs to understand polygon mesh formats, how different software handles materials and textures, what information is preserved or lost during format conversion, and how file structures impact rendering performance. This knowledge creates several forms of professional value. First, it prevents errors before they happen. When you understand formats and pipelines, you structure your work to avoid problems, rather than fixing problems after they occur. You choose formats that preserve necessary information. You establish workflows that minimize quality degradation. You avoid incompatible tools before wasting time on work that won't transfer properly. Second, it enables efficient collaboration. When working with others, format knowledge lets you provide exactly what they need in the form they need it. A graphic designer sending files to a printer knows to provide CMYK files at 300 dpi with bleed and crop marks, not RGB screen resolution files. A developer sharing data knows whether to use JSON, CSV, or a database dump based on how the recipient will use it. This consideration saves hours of back and forth and establishes you as a professional to work with. Third, it enables workflow optimization. When you understand how data flows through systems, you can identify inefficiencies and create better processes. Maybe you realize that converting formats 3 times in your current workflow is degrading quality and wasting time. You restructure to reduce conversions. Maybe you identify that certain tools in your pipeline don't communicate well, and a different tool sequence would be more efficient. These optimizations only become visible when you understand the underlying data flow. Fourth, it makes automation possible. This connects directly to the workflow automation we discussed earlier. To automate effectively, you need to understand what data moves between steps, in what format, and what transformations are needed. A professional who treats every file as a black box can't build automation because they don't understand what the automation needs to do. A professional who understands formats can script conversions, build data pipelines, and create systems that work reliably without manual intervention. Let's get specific about what this knowledge actually entails, because understanding file formats sounds abstract until you break it down into concrete components. At the most basic level, it means understanding the difference between file types and what that implies. Text files versus binary files. Compressed versus uncompressed. Lossy versus lossless compression. Open formats versus proprietary formats. Each distinction has practical implications for how you work with files, what you can do with them, and what limitations they impose. A text file is human-readable if you open it in a text editor, useful for debugging, editing, and version control. A binary file is not human-readable, more efficient for computers, but opaque to human inspection. Understanding this distinction helps you choose appropriate formats. Configuration files are often text because developers need to read and edit them. Image files are binary because the efficiency matters more than human readability. Compressed files are smaller, but require decompression to use. This is fine for storage and transfer, but adds processing overhead. Uncompressed files are larger, but immediately accessible. The choice depends on your priorities. Are you optimizing for storage space, transfer speed, or processing speed? Different scenarios have different answers. Lossy compression reduces file size by discarding information. Acceptable for many purposes, but irreversible. Lossless compression reduces size without information loss. Necessary when you need to preserve quality. A photographer exporting for print uses lossless formats to preserve maximum quality. The same photographer exporting for web might use lossy compression because the quality trade-off is worth the faster load times. Open formats have publicly documented specifications that any software can implement. Proprietary formats are controlled by specific companies. This affects long-term accessibility, cross-platform compatibility, and workflow flexibility. A business storing records in proprietary formats is vulnerable if that software becomes unavailable. Using open formats provides independence from any single vendor. Beyond basic format knowledge comes understanding data structures within formats. An image file isn't just pixels. It includes metadata, color profiles, layer information if applicable, and various other data depending on format. A document file includes text, formatting, styles, embedded media, and metadata. Understanding what's in a file helps you preserve what matters during conversions and strip what doesn't. This gets practical quickly. You're creating a portfolio website and want to include project images. Do you upload the original Photoshop files with all layers? Of course not. They're huge and browsers can't display them. You export to JPEG or PNG, but should you strip metadata? If your camera information is in there, maybe you want to keep it to show what equipment you use. Or maybe you want to remove it for privacy. This isn't a one-size-fits-all decision. It requires understanding what's in the file and what matters for your purpose. The next level is understanding transformations and conversions. Anytime you move data from one format to another, something might change. Sometimes this is intentional and beneficial, converting a large uncompressed image to compressed format for web use. Sometimes it's unintentional and problematic, losing metadata you needed to preserve, degrading quality through repeated compression, or failing to maintain certain features that don't exist in the target format. A common example: converting between document formats. A complex Word document with custom styles, embedded fonts, and specific formatting might not convert cleanly to Google Docs. Some formatting will be lost or changed. Tables might break. Embedded images might shift. Understanding these limitations lets you either choose formats that preserve what matters or adjust your workflow to minimize problems. The principle extends to any data transformation. Converting between 3D model formats might lose material information, animation data, or rigging details. Converting between audio formats might change sample rates, bit depths, or metadata. Converting between spreadsheet formats might break formulas, lose conditional formatting, or change how dates are handled. Every conversion is an opportunity for information loss or transformation, and understanding this helps you control the process rather than being surprised by results. This brings us to pipelines, sequences of tools and transformations that data moves through from initial creation to final use. Every professional workflow is a pipeline, whether formalized or not. Understanding your pipeline means understanding each step, what happens at each step, what format data takes between steps, and where problems might occur. A video production pipeline might look like: shoot footage, camera raw format, import to editing software, converted to editing-friendly format, edit, working in timeline with multiple tracks, add effects, applied to timeline, export, converted to distribution format, upload to platform, platform may re-encode. Each step has implications. Understanding the pipeline helps you make smart decisions. Shooting in a format your editing software handles well. Editing at a resolution appropriate for final output. Exporting in settings that minimize quality loss. And providing uploads that require minimal platform re-encoding. Understanding pipelines also reveals optimization opportunities. Maybe your current pipeline includes redundant conversions or quality degrading steps. Maybe you're using intermediate formats that don't preserve information you need later. Maybe you could restructure the pipeline to be more efficient or maintain higher quality. These improvements only become apparent when you can see the entire data flow clearly. Here's a real-world example of pipeline understanding creating competitive advantage. A digital agency produces client presentations that include data visualizations, mock-ups, and video demos. Their original pipeline: analysts create charts in Excel, designers screenshot them and touch up in Photoshop, video team records screen demos in full resolution, editors cut them down, and everything gets assembled in PowerPoint for delivery. This pipeline has multiple problems that only become obvious with format knowledge. Screenshots of Excel charts are raster images that look terrible when scaled. Recording full resolution screen video creates enormous files that slow editing. PowerPoint has file size limits that they constantly hit. The team spends hours compressing, resizing, and troubleshooting format issues. Someone with format understanding redesigns the pipeline. Analysts export charts as vector SVGs that scale perfectly. Designers work with vectors directly, maintaining quality at any size. Video team records at presentation resolution from the start, eliminating unnecessary file size. Everything goes into a web-based presentation tool that handles large media better than PowerPoint. The result? Better quality output, smaller files, faster workflow, and fewer technical problems. This wasn't about using different software. It was about understanding data formats and structuring the pipeline to work with those formats effectively. That understanding saved the team hours every week and improved client deliverables noticeably. The strategic implication is that format and pipeline knowledge becomes a form of professional infrastructure. It's not your primary skill. You're not a file format expert by profession, but it's foundational knowledge that makes everything else work better. Like understanding grammar if you're a writer, or understanding basic accounting if you run a business. The knowledge isn't the point. It's the enabler that makes your actual work more effective. This knowledge is also increasingly valuable in AI-integrated workflows. When you're connecting AI tools to your workflow, you need to understand what format data needs to be in for the AI to process it, what format it outputs, and how to transform between formats efficiently. An AI tool might expect JSON input, but you have CSV data. Understanding both formats lets you write a quick conversion script. Without that understanding, you're stuck manually reformatting data or unable to use the tool effectively. Consider a content creator using AI for video subtitles. The AI generates subtitles in SRT format. She needs them in her video editor, which expects a different subtitle format. Understanding subtitle formats lets her either convert the SRT file to the needed format or import it directly if her editor actually supports SRT, but she didn't realize it. Without format knowledge, she might retype subtitles manually or abandon AI assistance entirely. Or a researcher using AI to analyze documents. The AI works best with plain text, but her documents are PDFs with complex formatting. Understanding file formats helps her extract text while preserving structure, or recognize when PDF formatting is preventing effective extraction, or choose different document formats for future work. This knowledge multiplies AI's usefulness by ensuring data flows correctly between tools. The automation potential is even greater. Building efficient automated workflows requires understanding how data moves through systems. What format does each tool expect? What format does it output? What transformations are needed between steps? Can those transformations be automated? A professional with format knowledge can build robust automation. A professional without that knowledge hits constant technical barriers. Let's talk about how to develop this knowledge, because it's not typically taught systematically. Most professionals learn it gradually through painful experience. Trying to open files that don't work, losing data in conversions, troubleshooting compatibility problems. This learning path works, but it's inefficient and frustrating. Better to develop format literacy deliberately. Start by actually looking at file contents. Take files you work with regularly and open them in a text editor for text-based formats or a hex editor for binary formats. You won't understand everything, but you'll start seeing structure. An HTML file opened in a text editor shows you tags, structure, and content clearly. An SVG file is actually XML that describes vector graphics mathematically. A JSON file stores data in human-readable name-value pairs. Seeing these formats demystifies them. They're not magic. They're structured data that follows specific rules. Read documentation for formats you use frequently. Most common formats have specifications or guides available. Understanding what's officially part of a format versus what's software-specific helps you make portable choices. Learning what metadata a format can store helps you preserve or strip information intentionally rather than accidentally. Experiment with conversions deliberately. Take a file and convert it between formats, examining what changes. Convert an image between JPEG and PNG and back, comparing quality. Convert a document between Word and PDF and back, seeing what formatting survives. Convert between video formats with different codecs, checking file sizes and quality. This experimentation builds intuition about what's preserved and what's lost in common conversions. Learn basic scripting for file manipulation. Even simple scripts can be powerful. A Python script that converts CSV to JSON, or resizes all images in a folder, or extracts specific data from structured files. Writing these scripts forces you to understand file formats programmatically, which deepens your knowledge considerably. And these scripts become tools in your workflow, saving time on repetitive format tasks. Study your own workflows systematically. Map out where files move, what formats they take at each step, and where conversions happen. Identify pain points. Where does quality degrade? Where do files break? Where does compatibility cause problems? Each pain point is a learning opportunity. Understanding why it's happening helps you fix it permanently rather than working around it repeatedly. Pay attention to error messages. When file operations fail, error messages often contain useful information about format expectations. A message saying invalid JSON syntax at line 47 tells you exactly where to look. An error about unsupported codec tells you what's missing. Most people just see error and give up. Format-literate professionals read errors as diagnostic information. This knowledge compounds over time. Each format you understand makes the next one easier to learn because you start recognizing patterns. Text-based formats often have similar structures. Image formats share common concepts like resolution, color depth, and compression. Video formats build on audio and image format concepts. Document formats often embed other formats. Understanding one domain makes adjacent domains more accessible. The competitive advantage this creates is subtle but real. You don't market yourself as a file format expert. That's not a job title anyone cares about. But this knowledge makes you more efficient, more reliable, more capable of handling technical challenges, and more valuable as a collaborator. It's professional infrastructure that makes everything else you do work better. In teams, this knowledge often makes you the person others come to when files won't open, formats won't convert, or workflows aren't working. This creates visibility and value that accelerates career growth. You become known as someone who understands how things actually work, not just how to click buttons. That reputation matters. In solo professional work, format knowledge means fewer roadblocks and more capability. You can work across platforms more easily. You can collaborate with a wider range of tools and clients. You can build automated workflows that others can't. You can troubleshoot problems independently rather than being blocked by technical issues you don't understand. And critically, this knowledge is largely immune to AI disruption. AI can help with format conversions if you know what conversion you need. But identifying that you need a conversion, understanding what's lost in the process, and structuring workflows to minimize format problems, these require human understanding that AI currently cannot replicate. AI doesn't understand your complete workflow context or quality requirements. It can execute conversions you specify, but you need to specify them correctly. This is similar to the mastery concept we discussed earlier. Just as deep tool knowledge creates professional moat, deep format and pipeline understanding creates workflow robustness that AI enhances rather than replaces. You use AI to automate conversions, but you design the pipeline. You use AI to process files, but you ensure formats are correct. You use AI for data transformation, but you verify integrity is maintained. The professionals struggling most with AI integration are often those with the least understanding of their own workflows. They don't know what data they need in what format at what steps. They don't understand where quality degrades or why. They can't articulate what needs to happen between tools. This lack of understanding makes effective AI integration nearly impossible, because they can't specify requirements clearly. Conversely, professionals with strong format and pipeline knowledge integrate AI smoothly because they understand exactly where it fits. They know which format transformations can be automated, which require judgment, and how to verify results. They build AI into workflows systematically, rather than trying to use it ad hoc and hoping it works. This brings us back to the fundamental theme running through everything we've discussed. AI amplifies capability for those who have clear understanding and exposes weakness for those who don't. File format and pipeline knowledge is part of that foundational understanding. It's not glamorous knowledge. Nobody writes inspirational LinkedIn posts about learning file formats. But it's the kind of unglamorous, practical knowledge that separates professionals who control their workflows from those who are controlled by them. In an AI-saturated professional landscape, that control matters more than ever, because the professionals who thrive won't be those who can prompt AI most cleverly, They'll be those who understand their work deeply enough to integrate AI strategically, who know their tools thoroughly enough to push boundaries, who understand their workflows clearly enough to optimize systematically, and who grasp formats and pipelines well enough to build robust, efficient systems that AI enhances. This is the hidden curriculum of professional success in an AI age. Not the flashy skills that get attention, but the foundational knowledge that makes everything else possible. The understanding that turns software from a black box into a transparent system you can manipulate. The literacy that turns error messages from mysteries into diagnostic information. The expertise that turns format incompatibilities from workflow killers into solvable problems. And here's the final insight about format and pipeline knowledge. It's knowledge that remains valuable regardless of which specific tools are current. The file formats and software we use today will be replaced. The underlying concepts won't be. Understanding how data is structured, how it transforms between representations, how quality is preserved or degraded, how compatibility is maintained. These principles transcend any particular technology. They're as relevant to understanding future tools as they are to mastering current ones. This makes format literacy one of the best investments you can make in your professional development. Not because knowing the technical specifications of PNG versus JPEG is intrinsically valuable, but because the thinking pattern that makes you curious about those specifications is the same thinking pattern that will keep you professionally relevant as technology evolves. It's the pattern of wanting to understand how things actually work, not just how to use them. Of caring about what happens underneath the interface, not just what buttons to click. That curiosity, that desire to understand systems rather than just operate them. That willingness to dig deeper than surface functionality. That's what separates professionals who will thrive from those who will struggle. Not because the specific knowledge matters in itself, but because the mindset that drives you to acquire that knowledge is the mindset that adapts to whatever comes next. Format and pipeline knowledge is just one expression of this deeper principle. Professional value in an AI-integrated world increasingly comes from understanding systems, not just operating within them. From seeing workflows as design systems that can be analyzed and optimized, not just as how we've always done things. From treating technical challenges as puzzles to solve through understanding, not just obstacles to work around through trial and error. This is the meta skill that makes everything else we've discussed possible. You can't effectively prompt AI without understanding what you're trying to achieve systematically. You can't master professional tools without understanding the systems they operate within. You can't automate workflows without understanding data flow. You can't solve problems effectively with AI assistance without understanding the problem space well enough to evaluate solutions. And you certainly can't build a career that's AI resistant without understanding your work at a level that goes beyond surface execution. Because AI is very good at surface execution. What AI cannot do is understand context, exercise judgment, design systems, or operate with the deep literacy that comes from genuine expertise. That literacy, whether it's tool literacy, format literacy, domain literacy, or workflow literacy, is what human professionals bring to AI-integrated work. AI provides speed, scale, and computational power. Humans provide understanding, judgment, and strategic direction. And the professionals who combine these effectively, who use AI to amplify human capability rather than replace it, who understand their work deeply enough to integrate AI strategically, they're not being disrupted by AI. They're being empowered by it in ways that create genuine competitive advantage. This is the reality of professional work in an AI age. Not human versus machine, not worried about replacement, not questioning whether to adopt AI, but rather, how deeply do you understand your work? How systematically can you think about your workflows? How clearly can you articulate what you're trying to achieve? How effectively can you evaluate whether solutions actually solve your problems? These questions aren't about AI. They're about professional competence at a level most people never reach because they've never been forced to. AI is the forcing function. It's making visible the difference between professionals who truly understand their work and those who've been executing without comprehension. Between those who can direct powerful tools effectively and those who are merely competent operators of familiar systems. And in that revelation lies both challenge and opportunity. Challenge because surface-level competence that was sufficient yesterday isn't sufficient today. Opportunity because developing genuine understanding creates value that AI cannot replicate and competitors cannot easily match. The choice is yours. You can continue clicking buttons without understanding what happens underneath, using AI as a black box that sometimes helps and sometimes doesn't, hoping that being busy enough compensates for lack of strategic integration. Or you can invest in understanding your tools, your formats, your workflows, your problem spaces, and use that understanding to integrate AI in ways that multiply your capability rather than just substituting for it. One path leads to increasing anxiety about AI replacement. The other leads to increasing confidence in AI-enhanced capability. The difference isn't about the technology. It's about the depth of your professional understanding and the strategic sophistication of how you apply it. Choose wisely, because the window for developing this understanding while AI is still being integrated rather than fully integrated is narrowing. The professionals establishing themselves as experts in AI-augmented work right now are building advantages that compound over years. The professionals waiting, hoping AI will go away or that their current skills will remain sufficient, are building liabilities that will become harder to overcome as time passes. The future of professional work isn't about humans or AI. It's about humans with AI versus humans without it. And more specifically, it's about humans who understand their work deeply enough to use AI strategically versus humans who don't. Which side of that divide you end up on is entirely within your control, but only if you act while the opportunity exists. There's a type of professional question that reveals everything about how someone thinks. Ask them to explain how they do their job, and listen carefully to their answer. Most people will describe a sequence of actions. First, I open this program. Then I click here. Then I enter this data. Then I export to this format. Then I send it to this person. They're describing buttons they press, screens they see, steps they follow. Now, ask an expert in the same role the same question. Their answer sounds completely different. I need to ensure data integrity flows from collection through analysis to reporting, so I've designed a validation system at each handoff point. The constraint is that source data arrives in inconsistent formats, so normalization happens early. The dependency chain means errors in validation block downstream analysis, which is why that's the most carefully monitored step. The output needs to serve 3 audiences with different technical levels, so the system generates 3 views from a single dataset. Same job, completely different level of thinking. The first person sees actions. The second person sees systems. And in an AI-saturated professional environment, that difference is everything. AI is exceptionally good at actions. Tell it, write a function that validates email addresses. and it will produce working code. Tell it, create a social media post about this product, and it will generate reasonable content. Tell it, summarize this document, and it will extract key points. AI excels at discrete, well-defined tasks that have clear inputs and outputs. What AI cannot do, at least not yet, not reliably, is think in systems. It cannot look at your entire workflow and identify that the bottleneck isn't where you think it is. It cannot recognize that a problem you're experiencing in Step 7 is actually caused by how you structured Step 2. It cannot anticipate that the solution you're considering will create downstream problems in areas you haven't thought about. It cannot design a workflow from scratch that elegantly handles complexity, dependencies, and edge cases. That's human work. That's systems thinking. And it's becoming the core differentiator between professionals who are irreplaceable and those who aren't. Let me show you what systems thinking actually looks like, because it's not an abstract concept. It's a practical skill that manifests in everyday professional work. A product manager is responsible for a new feature launch. The button-level thinker approaches this as a sequence. Design the feature, build the feature, test the feature, launch the feature. They move through these steps linearly. When problems arise, they solve them individually. A bug appears, they fix it. Users are confused, they write documentation. Sales team isn't prepared, they schedule a training. The systems thinker approaches the same launch completely differently. Before anything is designed, they map the entire system. Development dependencies, cross-team coordination points, user communication touchpoints, support preparation requirements, marketing timing constraints, technical infrastructure needs, and feedback collection mechanisms. They identify critical paths, which elements depend on which others. They recognize that user documentation needs to be written by someone who understands both the technical implementation and user context, so that dependency needs to be scheduled carefully. They see that sales training must happen after the feature is stable, but before marketing creates demand, defining a specific time window. When problems arise, and they always do, the systems thinker doesn't just solve the immediate issue. They ask, why did this problem occur? What system condition allowed it? What other problems might stem from the same root cause? How does fixing this impact other parts of the system? A bug isn't just a bug. It's information about whether testing processes are adequate, whether development and QA are communicating effectively, whether requirements were specified clearly. Solving the bug matters. Understanding the system failure that allowed the bug matters more. This distinction appears everywhere once you start looking for it. A systems thinking accountant doesn't just track expenses. They design financial systems that make certain errors impossible, flag anomalies automatically, and generate insights that drive business decisions. A systems thinking teacher doesn't just deliver lessons. They design learning systems that accommodate different paces, identify struggling students early, and build concepts sequentially so later learning builds on solid foundations. The pattern is consistent. Systems thinkers see processes, relationships, dependencies, feedback loops, and emergent behaviors. Button thinkers see actions, steps, and tasks. Why does this matter for AI integration? Because AI operates at the task level. When you give AI a well-defined task, it performs admirably. When you need someone to understand how tasks fit together into functioning systems, AI falls short. It might complete every individual task perfectly, while the overall system fails because the tasks weren't coordinated correctly, or because task outputs don't align properly, or because dependencies weren't respected. A practical example. A company wants to automate their customer onboarding process. They identify 10 tasks currently done manually. Send welcome email, create account, assign account manager, schedule kickoff call, send documentation, configure system settings, train on basic features, verify setup completion, collect initial feedback, and transition to regular support. The button-level approach. Automate each task individually. Use AI to generate personalized welcome emails. Script account creation. Auto-assign account managers based on availability. Automatically schedule calls. Send documentation via automated email. Configure common settings by default. Provide video training links automatically. Check completion through automated surveys. Collect feedback through forms. Transfer to support automatically after 30 days. This seems comprehensive. Every task is automated. It will fail. Why? Because automating tasks without understanding the system creates brittle automation that breaks when reality doesn't match assumptions. What happens when a customer needs a specific account manager who isn't auto-assigned? What if they need non-standard configuration that the defaults don't cover? What if they're not ready for training because setup isn't actually complete despite the automated check? What if feedback reveals a problem, but there's no process to act on it? The systems thinking approach looks completely different. Before automating anything, they map the actual system. What's the goal of onboarding? Customer success and rapid value realization. What are the dependencies? Training requires completed setup. Account manager assignment impacts all subsequent interactions. Configuration affects which features are accessible. What are the variations? Different customer sizes need different approaches. Different industries have different requirements. Different technical sophistication levels need different support. What are the feedback mechanisms? How do we know onboarding is working? What signals indicate problems? How do we improve based on what we learn? With this systems understanding, automation is designed differently. Instead of automating every task, they automate what's truly routine and build decision points where human judgment matters. Welcome emails are templated but customized based on customer segment. Account creation is automated but triggers manual review for non-standard cases. Account manager assignment considers customer needs, not just manager availability. Kickoff calls are scheduled automatically, but include prep work that reviews customer context. Configuration starts with smart defaults, but flags when customization might be needed. The result is a system that handles routine cases efficiently while escalating exceptions appropriately. It's resilient because it's designed around understanding how things actually work, not just automating visible tasks. And crucially, it improves over time because it includes feedback mechanisms that reveal where the system isn't working. This is systems thinking in practice. Not just automating tasks, but designing systems that accomplish goals reliably, while handling the complexity, variation, and exceptions that real work always includes. So how do you develop systems thinking? Because most people aren't taught this explicitly. They learn tasks, procedures, best practices. They don't learn to see systems. But it's a learnable skill, and it's arguably the most important skill to develop for professional relevance in an AI age. Start by mapping your own workflows completely. Not just the happy path where everything works, but the actual workflow, including exception handling, error correction, and variation. Use paper or a whiteboard. Draw boxes for each step. Draw arrows for information flow. Mark dependencies. Which steps must happen before others? Identify decision points. Where does judgment determine what happens next? Note constraints. What limits what's possible? This mapping exercise forces you to articulate what you actually do, not what you think you do. Most professionals discover their mental model of their workflow doesn't match reality. They thought step A always led to step B, but actually it sometimes leads to step C, depending on a condition they weren't consciously tracking. They thought they worked linearly, but actually they're constantly looping back to refine earlier work based on later insights. Making this implicit system explicit is the first step toward understanding it well enough to improve it. Next, identify systemic patterns. Where do errors occur most frequently? That's usually indicating a systemic issue, not a personal failure. Maybe information isn't flowing cleanly between steps. Maybe a dependency isn't being respected consistently. Maybe a decision point lacks clear criteria, so different people make different choices. Where do delays happen? Delays often reveal dependencies that aren't managed well, or bottlenecks where capacity doesn't match demand, or handoffs between teams that require coordination overhead. Where does rework happen? Rework means the system is producing output that doesn't meet requirements, which indicates either unclear requirements, inadequate validation, or misalignment between what's being produced and what's actually needed. These patterns aren't random. They're symptoms of system design, and recognizing them lets you address root causes instead of just treating symptoms. Then, practice thinking in second-order effects. When you're considering a change, don't just ask, "Will this solve the immediate problem?" Ask, "What else will this affect?" Every system change has ripple effects. Sometimes those effects are beneficial. Fixing one problem improves related areas. Sometimes they're problematic. Solving one issue creates new issues elsewhere. A marketing team decides to increase email frequency to boost engagement. First-order thinking. More emails means more opportunities for engagement, so engagement should increase. Second-order thinking. More emails might increase engagement initially, but could lead to higher unsubscribe rates, lower open rates over time as people get fatigued, and damage to brand perception if emails feel spammy. The optimal frequency balances these competing effects. A development team decides to automate testing to speed up releases. First-order thinking. Automated tests run faster than manual tests, so we can release faster. Second-order thinking. Automated tests need to be written and maintained, which takes development time. They might not catch all the issues manual testers would find. Faster releases with more bugs might be worse than slower releases with fewer bugs. The system needs to balance speed with quality. This second-order thinking is hard because it requires imagining consequences that haven't happened yet. But it's essential for systems thinking. You're not just solving immediate problems. You're designing systems that behave well under various conditions. Another practice. Analyze systems you interact with as a user or customer. When you encounter a frustrating experience, think systemically about why it exists. A retail store consistently has long checkout lines. Button thinking. They need more cashiers. Systems thinking. Why are checkout lines the bottleneck? Is it payment processing speed? Are cashiers handling multiple tasks beyond checkout? Is there a scheduling issue where peak traffic times don't align with staffing? Is the checkout process inefficient? Each root cause suggests different solutions, and the right solution depends on understanding the actual system constraint. This external analysis builds your pattern recognition for systems dynamics. You start seeing common patterns, coordination problems, capacity mismatches, misaligned incentives, information gaps, feedback delays. These patterns appear across different domains, and recognizing them in unfamiliar contexts helps you spot them in your own work. As you develop systems thinking, you'll notice your approach to problems changes fundamentally. You stop asking, "How do I do this task?" and start asking, "How should this system work?" You stop solving problems individually and start designing solutions that address classes of problems. You stop thinking about your work as a job and start thinking about it as a system you're responsible for optimizing. This shift is powerful because it makes you dramatically more valuable. Task execution can be automated or outsourced. System design and optimization requires judgment, contextual understanding, and strategic thinking that AI cannot replicate. Consider how this plays out with AI assistants. A button thinker uses AI to complete individual tasks. Write this email, analyze this data, create this graphic. They're using AI as a task execution tool. Their relationship with AI is transactional. They ask for outputs, they receive outputs, they use outputs. A systems thinker uses AI completely differently. They understand their workflow as a system and identify where AI can improve system performance. Maybe AI can handle routine data validation, freeing them to focus on anomaly investigation. Maybe AI can generate first drafts, letting them spend more time on strategic messaging. Maybe AI can monitor system metrics, alerting them to issues before they become critical. The systems thinker isn't just using AI for tasks, they're integrating AI into their system architecture. They're designing their workflow so AI handles what AI does well, while they focus on what humans do well. They're creating feedback loops where AI output informs their decisions, and their decisions improve AI prompting over time. They're building systems that are more capable than either human or AI alone. This integration is only possible with systems thinking. Without it, AI is just another tool you use sometimes. With it, AI is a component in a sophisticated system you've designed to achieve your professional goals efficiently and effectively. Let me give you a concrete example of this difference. A content strategist needs to produce regular blog posts, social media content, and email newsletters. All three content types need to align strategically, maintain brand voice, and serve the overall marketing goals. Button thinking approach. Use AI to generate blog posts. Use AI to generate social posts. Use AI to generate newsletters. 3 separate tasks, 3 separate AI interactions. Done. The problem? The content doesn't actually align. Blog posts discuss one set of themes, social posts another, newsletters a third. Voice is inconsistent because each AI generation starts from scratch. Strategic goals aren't met because there's no coherent system ensuring everything works together. Systems thinking approach. Design a content system. Start with monthly strategic themes that align with business goals. Create a master content calendar showing how blog posts, social content, and newsletters support each theme. Develop a brand voice guide that all content follows. Build a workflow where blog posts are primary content, social posts highlight key points from blogs, and newsletters synthesize the month's themes. Now integrate AI into this system. AI helps brainstorm theme angles based on research. AI generates blog first drafts following the brand guide. AI creates social post variations from blog content. AI drafts newsletter summaries of blog themes. But the human is designing the system, ensuring strategic alignment, maintaining voice consistency, and verifying that everything serves the larger goals. The result is content that's strategically coherent, consistently branded, and efficiently produced. The AI multiplies productivity, but the human systems thinking is what makes it work. Without that thinking, you just have a lot of disconnected AI-generated content that doesn't accomplish anything meaningful. This is the fundamental shift that professionals need to make. From seeing AI as a tool that does tasks, to seeing AI as a component in systems you design. That shift requires systems thinking. It requires understanding your work not as a collection of tasks, but as a system with goals, constraints, dependencies, and feedback loops. And here's the crucial insight. This systems thinking protects you from AI disruption in a way that task expertise doesn't. If your value is, I can write blog posts, AI is directly competing with you. If your value is, I design content systems that achieve strategic goals through coordinated multi-channel messaging with consistent brand voice and measurable business impact, AI is amplifying your capability, not replacing it. The systems thinking is the moat. It's what AI cannot easily replicate because it requires contextual understanding, strategic judgment, and the ability to design for complexity that AI currently lacks. AI can execute within systems brilliantly. AI cannot design sophisticated systems that handle real-world complexity, variation, and competing constraints. This brings us to a counterintuitive truth. The more AI handles individual tasks, the more valuable system-level thinking becomes. Because someone needs to design how all those AI-executed tasks fit together into coherent workflows. Someone needs to ensure the outputs align with goals. Someone needs to monitor system performance and adjust when things aren't working. Someone needs to anticipate problems and build resilience into systems. That someone needs to think in systems, not buttons. They need to see the forest, not just trees. They need to understand how components interact, not just what each component does. They need to design for real-world complexity, not just ideal case scenarios. This is the skill set that defines professional value in an AI age. Not resisting AI. Not trying to do what AI does better, but rather operating at a level of abstraction where AI's task execution becomes a powerful tool you wield as part of a larger system you've thoughtfully designed. And the beautiful thing about systems thinking is that it applies everywhere. Whether you're in marketing, finance, operations, design, development, research, or any other field, your work involves systems. Understanding those systems, improving them, and designing new ones that perform better. That's universal professional value that transcends any specific role or industry.
There's a management principle that's been true for decades.
If you can't delegate effectively, your career tops out early. You can only accomplish so much through personal execution. Scaling impact requires leveraging others' capabilities. The best professionals aren't just good at their work, they're good at multiplying their effectiveness through others. Now apply this principle to AI. Most people treat AI as either a miracle solution or a disappointing tool. It's neither. It's a junior assistant with specific strengths and weaknesses that performs extremely well when managed correctly and poorly when not. Think about a capable junior employee. They're smart, quick learners, and can execute clearly defined tasks well. But they lack context about your company, experience with your industry's nuances, and judgment about what matters strategically. You wouldn't give them a vague instruction and expect perfect results. You wouldn't trust their work without review. You wouldn't blame them for not knowing things you haven't taught them. You would give them clear instructions, provide necessary context, check their work, offer feedback, and gradually increase responsibility as they prove capability. You'd leverage their strengths, energy, speed, willingness to handle tasks you don't want to do, while compensating for their weaknesses through your experience and oversight. This is exactly how you should use AI. Not as a peer who understands everything you do. Not as an expert whose outputs you trust blindly. But as a capable junior assistant who produces excellent results when managed well. Let me break down what this actually means in practice, because most people get this relationship wrong in ways that limit AI's usefulness. First, clear task assignment. Junior employees need specificity. Handle the client communication is too vague. Send the client a project update covering these 3 topics. Maintaining professional tone by end of day is actionable. AI is the same. Vague prompts produce mediocre results. Specific instructions produce quality output. But specificity isn't just about detail. It's about clarity of outcome. When delegating to a junior employee, you explain not just what to do, but why it matters and what success looks like. Same with AI. Write a product description is vague. Write a 100-word product description that emphasizes ease of use for non-technical users, includes our key differentiator of instant setup, and ends with a clear call to action is clear. The difference isn't just that the second prompt is longer, it's that you've defined success criteria. The AI knows what matters, what to emphasize, and what the output should accomplish. This is management basics. Define success before starting work. Second, provide necessary context. A junior employee needs context to make good decisions. They need to know who the client is, what the history is, what constraints exist, what the goals are. They'll make mistakes if you assume they know things you haven't told them. AI is worse at this because it has zero context about your specific situation unless you provide it. It doesn't know your company, your audience, your constraints, your goals, your brand voice, or any of the contextual information you carry unconsciously. Every AI interaction starts from zero unless you deliberately provide context. This means effective AI use includes context provision as standard practice. Before asking AI to draft client communication, you provide who the client is, what they care about, what you're trying to accomplish, what tone is appropriate, and what information needs to be conveyed. This seems like overhead, but it's actually efficient. The output is dramatically better because AI has the information needed to produce something useful. Smart professionals build reusable context. Instead of retyping company background every time, they save standard context documents. Here's our company description, brand voice guide, and key messaging points. They reference this context in AI prompts. Using the brand voice guide I provided earlier, draft, "This is exactly how you'd onboard a new junior employee. Give them documentation once, then reference it as needed." Third, verify outputs systematically. You wouldn't let a junior employee send client communication without review. You check their work. Not because you don't trust them, because they're learning and mistakes happen. Review catches errors before they matter. AI outputs require the same verification discipline. Not occasional spot checking, but systematic review of everything before using it. This isn't optional. AI produces confident-sounding outputs that can be completely wrong. It hallucinates facts, misunderstands instructions, and sometimes just makes stuff up while sounding authoritative. A junior employee who made up facts would be immediately flagged as problematic. AI does it regularly, and users often don't notice because the output sounds good. The solution isn't avoiding AI. It's building verification into your workflow as standard practice. What does verification look like? For factual content, it means checking claims against reliable sources. For code, it means testing thoroughly before deployment. For analysis, it means reviewing methodology and confirming conclusions make sense. For creative content, it means evaluating quality against your standards and brand requirements. This verification isn't just catching errors, it's also feedback that improves future outputs. When you notice AI made a mistake, note what caused it. Did you provide insufficient context? Was your instruction ambiguous? Did you need to specify a constraint you forgot? Learning from these issues makes your future prompts better. Fourth, provide corrective feedback. When a junior employee makes mistakes, you don't just fix their work silently. You explain what was wrong and why.
This teaches them to avoid similar mistakes in future. They improve because of your feedback. AI improves within a conversation through feedback too. Not in the sense of learning permanently. Each conversation starts fresh. But within that conversation, feedback shapes subsequent outputs. That draft is too formal. Make it conversational. Produces a revised version and also guides what AI generates next in that conversation. This iterative refinement is how you get great results from AI. First output is rarely perfect. You review it, identify what needs adjustment, provide specific feedback, and get an improved version. Repeat until satisfied. This is exactly how you'd work with a junior employee on a deliverable. Draft, feedback, revision, feedback, revision, until it meets standards. The key is specific feedback. This isn't quite right, doesn't help a junior employee or AI. The tone is too aggressive here, and this section needs more concrete examples, is actionable. Specific feedback produces better revisions and, in AI's case, trains it within the conversation to better understand your standards. Fifth, gradual capability expansion. You don't give a junior employee your most critical work on day one. You start with lower stakes tasks, verify they can handle those reliably, then increase responsibility. As they prove capability, you delegate more complex work. Same principle with AI. Start with low-stakes tasks where errors are easily caught and consequences are minimal. First drafts of content you'll heavily revise anyway. Background research you'll verify. Brainstorming ideas you'll evaluate critically. Initial data processing you'll check before analysis. As you develop confidence in AI's performance for these tasks, expand into higher stakes work. But gradually, with appropriate verification at each level. And always with the understanding that AI has limits. There are tasks you wouldn't delegate to even an experienced junior employee
because they require senior-level judgment. Those same tasks shouldn't go to AI unsupervised. This might sound like a lot of management overhead. Why not just do the work yourself if you're verifying everything anyway? Because even with verification, AI provides massive leverage. A junior employee who produces a 90% quality draft that you refine to 100% is incredibly valuable. They're doing 90% of the work. AI is similar. It handles the bulk of execution. You provide the refinement that makes it excellent. The ratio improves over time as you get better at prompting and verification becomes faster. Initially, you might spend significant time refining AI output. As you learn what instructions produce better first drafts, and as your verification gets more efficient, the leverage increases. Eventually, you're accomplishing in an hour what used to take a day, because AI is handling execution while you provide strategic direction and quality control. This is the leverage point most professionals miss. They expect AI to be perfect immediately, or they dismiss it as useless. Neither expectation is reasonable. AI is a tool that requires skilled use. Like any capable junior assistant, it performs brilliantly when managed well and disappoints when managed poorly. Let's look at what good AI management produces in practice. A researcher is analyzing interview data to identify themes. The manual approach. Read all interviews, take notes, categorize insights, identify patterns, synthesize findings. This takes days. With AI as a junior assistant, provide AI with interview transcripts and instructions. Analyze these interviews for common themes related to user frustration with current solutions. Identify specific quotes that illustrate each theme. Flag any contradictions or outliers. AI processes the transcripts and produces initial categorization in minutes. The researcher reviews AI's analysis.
Some categories are insightful. Some miss nuance.
Some quotes are miscategorized. She refines. This integration issues category is too broad. Split it into technical compatibility and workflow disruption themes. Move these 3 quotes to different categories where they fit better. AI produces revised analysis. Better, but still not perfect. She does another revision round, adding context AI missed and removing weak examples. After 3 iterations, she has solid categorized themes that captured insights AI found, plus her deeper understanding of context and nuance. Total time? 3 hours instead of 3 days. The AI didn't replace her expertise. It handled the mechanical sorting and initial pattern recognition, letting her focus on the interpretive work that requires judgment. She managed it like a junior assistant. Clear initial instruction, review of output, specific corrective feedback, iterative improvement, final quality control. This is what effective AI assistance looks like. Not magic, not disappointing, just well-managed leverage that multiplies productivity while maintaining quality. Now let's talk about common failure modes, because understanding what goes wrong helps you avoid these pitfalls. Failure Mode 1. Under specification. Giving AI vague instructions and being disappointed by vague results. This is like telling a junior employee, do something useful, and being frustrated they don't read your mind. The solution is clearer task specification. If outputs aren't meeting expectations, the problem is usually insufficient instruction clarity. Failure Mode 2. Overtrust. Accepting AI outputs without verification because they sound authoritative. This is like letting a junior employee send client deliverables without review because they seem confident. The solution is systematic verification, regardless of how good something seems. Confidence and correctness are uncorrelated in AI outputs. Failure Mode 3. Static prompting. Using the same vague prompts repeatedly and expecting improvement. This is like giving a junior employee the same inadequate instructions every day and wondering why they're not getting better.
The solution is iterative prompt improvement based on what you learn from previous outputs. Failure Mode 4. Inappropriate delegation. Giving AI tasks that require judgment, nuance, or context it cannot have. This is like asking a junior employee to make strategic decisions they're not equipped to make. The solution is understanding AI's appropriate scope and keeping certain work human-directed with AI support, rather than AI executed with human review. Failure Mode 5. No feedback loop. Using AI outputs without reflecting on what worked and what didn't. This is like never debriefing with a junior employee about their work. The solution is building reflection into your process. After using AI outputs, note what instructions produced good results and what needs adjustment. Avoiding these failure modes dramatically improves AI utility. You're not fighting the tool. You're using it appropriately within its capabilities. This brings up an important point about skill development. Managing AI effectively is a genuine skill. You get better at it with practice. Your prompts become more effective. Your verification becomes more efficient. Your understanding of AI's strengths and limitations becomes more nuanced. You develop instincts about what tasks AI handles well and what requires human judgment. This skill development is worth investing in because it compounds. Every hour you spend learning to use AI effectively pays dividends for years. You're not just learning a tool, you're developing capability in human-AI collaboration that will be increasingly valuable as AI becomes more ubiquitous in professional work. And here's something most people miss. Getting good at managing AI makes you better at managing humans too. The skills overlap substantially. Clear task definition, context provision, verification systems, feedback mechanisms, iterative improvement. These are core management capabilities. Practicing them with AI develops them generally. So if you're early in your career and don't manage people yet, treating AI as a junior assistant is excellent management practice. You're learning to delegate effectively, provide clear instructions, verify work systematically, and give constructive feedback. These skills transfer directly when you start managing actual people. If you already manage people, your existing management skills transfer to AI. You know how to break down complex work into delegatable tasks. You know how to provide context that makes execution effective. You know how to verify work without micromanaging. Apply these same skills to AI and it performs dramatically better than it does for people who've never managed others. The fundamental insight is this: AI isn't a person, but the relationship dynamics that make human teams effective also make human-AI collaboration effective. Clarity, context, verification, feedback, and iterative improvement. These principles work because they're about effective delegation and collaboration generally, not about the specific entity you're working with. This reframes AI from tool I use to assistant I manage. That mental shift unlocks dramatically better outcomes because you start thinking about AI integration strategically rather than transactionally. You're not just asking AI to do individual tasks. You're building a working relationship where AI handles certain types of work reliably, while you maintain oversight and provide direction. And as AI capabilities improve, this relationship becomes more productive. Your junior assistant is learning new skills, becoming faster, making fewer errors. But the relationship structure remains the same. You direct, AI executes, you verify, you provide feedback, you iterate toward excellence. This is how professionals will work in an AI-integrated future. Not replaced by AI, not competing with AI, collaborating with AI through effective management that leverages AI's strengths while compensating for its weaknesses through human judgment and oversight. The professionals who figure this out early have an enormous advantage. They're building productivity multipliers while their peers are still trying to figure out whether AI is friend or foe. They're developing systems and skills that let them accomplish in hours what takes others days. They're establishing themselves as go-to people who deliver quality quickly because they've mastered AI-human collaboration. This is the opportunity. Not using AI to replace your work, using AI to multiply your effectiveness through well-managed delegation that maintains quality while dramatically increasing output. Treating AI like the capable junior assistant it is, with appropriate instruction, verification, and oversight that lets you leverage its capabilities while avoiding its pitfalls. Master this, and you're not worried about AI disruption. You're experiencing AI multiplication. Your value isn't decreasing, it's compounding as you accomplish more and more with AI assistance, while your competitors are still doing everything manually or using AI poorly. Integration options. APIs let different software communicate. No-code platforms like Zapier or Make connect tools without programming. But integration requires intentional design. Tools don't just connect themselves. You need to architect how information flows through your stack. Map your actual workflow. What information moves from where to where? A typical workflow might be data arrives via email, gets processed in a spreadsheet, insights go into a presentation, which gets shared via collaboration platform. Each transition point is an opportunity for either smooth integration or friction. At transition points, ask, can this be automated? Should this be automated? What format conversions are needed? Where might errors occur? Design integration that minimizes manual handling, reduces format conversions, and includes error checking where it matters. A content creator's integrated stack might look like write in a focused writing app, edit in a grammar tool, format in a design tool, publish via content management system, track performance in analytics platform, schedule social promotion via management tool. Each step could be manual: copy, paste, reformat, upload. Or it could be integrated: automatic flow from writing through publishing with minimal manual intervention. The integrated version isn't just faster, it's more consistent, less error-prone, and mentally easier. You're not constantly switching contexts and handling logistics. You're focused on the actual work while your tech stack handles the mechanics. Now, add AI into your tech stack as a deliberate component, not an occasional add-on. This means having AI tools that integrate with your primary workflow, not just ChatGPT in a separate browser tab that you sometimes remember to use. Depending on your work, this might mean IDE extensions that provide AI code completion, writing tools with built-in AI assistance, design software with AI generation features, or automation platforms that include AI capabilities. The key is having AI available where you actually work, not requiring constant context switching to access it. For work that doesn't have built-in AI integration, create your own. This might be as simple as having an AI chat interface as a pinned tab you can quickly access. Or it might be more sophisticated: scripts that send data to AI APIs and return results directly in your workflow.
The goal is reducing friction between your work and AI assistants. This integration determines whether you actually use AI regularly or occasionally when you remember. If accessing AI requires stopping your work, switching contexts, and manually transferring information, you won't use it consistently. If AI is integrated into your natural workflow, you'll use it constantly because it's right there when you need it. Consider automation as a tech stack category. Automation tools range from simple keyboard macro utilities to complex workflow automation platforms. The right level depends on your technical comfort and your needs. But every professional should have some automation capability in their stack. At minimum, keyboard automation that lets you trigger complex actions with single keystrokes. This could be typing expansions. Typing ADDR expands to your full address. Application launching, or scripted sequences. These tools are usually simple to use and provide immediate productivity gains. More sophisticated automation connects multiple applications and handles complex workflows. This is where platforms like Zapier, Make, or custom scripts come in. These require more setup, but can eliminate hours of repetitive work permanently. The key is starting small and building gradually. Don't try to automate everything at once. Identify one repetitive task that annoys you. Automate it. Get comfortable with the tool. Then, automate another task. Over time, you build a collection of automations that collectively save significant time. Document your automations. This seems unnecessary until an automation breaks or you need to modify it months later and can't remember how it works. Simple documentation, what it does, how it's triggered, what data it uses, prevents frustration later. Your tech stack should also include specialized tools for specific needs that arise regularly. These aren't tools you use daily, but they're important enough to be in your arsenal. File format converters, data processing utilities, specialized calculators, backup systems, collaboration platforms, whatever your work requires. The test for whether a tool belongs in your stack. Do you need this capability regularly enough that having the tool ready is worth the cost and learning investment? If yes, add it properly. Install it, learn it adequately, integrate it with your workflow where appropriate. If no, use online tools or alternatives as needed, without adding complexity to your permanent stack. Every tool in your stack has maintenance cost, updates, learning curve, cognitive overhead. Minimize that cost by being selective about what you include permanently versus what you access occasionally. Cloud storage and backup deserve special mention because they're foundation infrastructure many people neglect until disaster strikes. Your work exists digitally. Digital data can be lost. Having robust backup systems isn't optional. It's professional basic hygiene. This means both cloud backup, automatic sync of important files to cloud storage, and local backup, regular backups to external drives. Cloud backup protects against hardware failure. Local backup protects against cloud service issues or internet outages. Both together provide real security. Beyond backup, cloud storage enables workflow improvements. Files available everywhere mean you can work from any device. Shared folders enable collaboration. Version history means you can revert mistakes. These benefits are significant enough that cloud storage should be foundational in any modern tech stack. Version control is another foundational element most non-developers ignore. Version control systems track changes over time, let you revert to earlier versions,
and enable collaboration without overriding each other's work. Developers use Git universally. Non-developers should too, at least for important work. This doesn't require becoming a Git expert. Basic version control, committing changes regularly with descriptive messages, provides enormous value. You can always go back to earlier versions. You can see what changed when. You can experiment without fear of breaking things permanently. These capabilities are valuable regardless of profession. Security tools are infrastructure many people neglect. Password managers, two-factor authentication, VPN for public networks. These protect your digital work from common threats. A single security incident can cost far more time than prevention requires. Build security into your stack as default practice, not something you add after problems occur. Now, let's talk about the meta layer, how you manage your tech stack itself. This includes learning resources, documentation systems, and update management. Learning resources. Every tool in your stack should have learning resources you know about. Official documentation, tutorial sites, communities where experts share knowledge. When you hit limitations or problems, knowing where to find answers is valuable. Bookmark these resources. Organize them. Make finding help quick rather than requiring research every time. Documentation. Document your own setup. What tools do you use? How are they configured? What automation exists? What integrations are active? This documentation is insurance against forgetting your own systems. It's also invaluable when setting up new machines or helping colleagues implement similar systems. This documentation doesn't need to be elaborate. Simple notes about what each tool does, why you chose it, key settings, and important shortcuts. Update it when you make significant changes. Refer to it when you need to replicate your setup. Update management. Software updates constantly. Some updates are important, security fixes, critical bugs. Some are optional, new features you don't need. Some break existing workflows, incompatible changes. You need a strategy for handling updates that balances security, stability, and new capabilities. For critical tools, research updates before applying them. Read change logs. Check whether automation or customization might break. Test in non-critical situations if possible. For less critical tools, automatic updates are usually fine. The key is being intentional rather than updating randomly or never updating. Periodically review your entire tech stack. What's working well? What's causing friction? What tools have you stopped using? What new capabilities do you need? This review prevents stack bloat, accumulating tools you don't really use, and identifies optimization opportunities. During review, ask, does this tool still serve my needs? Are there better alternatives now? Can I consolidate tools? Are integrations still working? Is automation still reliable? This maintenance keeps your stack optimized rather than letting it degrade over time. Consider the cognitive weight of your stack. Every tool you use requires mental space, remembering it exists, knowing how to use it, managing accounts and credentials. This cognitive overhead is real. A stack with 30 tools might offer marginally more capability than a stack with 15 tools, but the cognitive cost might not be worth it. Prefer depth over breadth. Better to master 15 tools and use them excellently than to sort of know 30 tools and use them poorly. This connects back to the mastery principle. Depth creates more value than breadth, even for your tech stack. Now let's address the financial aspect, because tech stacks cost money. Professional software isn't free.
subscriptions add up. You need to balance capability against cost in ways that make sense for your situation. For employed professionals, much software may be provided by employers. Use what's available well before paying for alternatives yourself. If you need tools your employer doesn't provide, make a case for the business value. Often, employers will pay for tools that make you more effective. For freelancers and business owners, software is a business expense that should be evaluated on ROI. Does this tool save time or enable capability worth more than its cost? If yes, it's a good investment. If it's just nice to have, reconsider. Free and open source tools are worth exploring. Many professional-grade tools are free. They may lack some polish compared to commercial alternatives, but often they're more than adequate. Don't assume expensive means better. Evaluate based on actual needs. For expensive tools, consider whether you need perpetual access or occasional use. Some software can be subscribed to for specific projects rather than year-round. Others offer student or startup discounts that make them more accessible. Some have free tiers with enough capability for many use cases. The goal isn't minimizing cost, it's optimizing value. Cheap tools that don't meet your needs waste money. Expensive tools that dramatically improve your work are worth every dollar. Evaluate based on impact, not just price. Build your stack gradually. Don't try to implement the perfect system immediately. Start with basics. Add tools as needs become clear. This evolutionary approach is both financially sustainable and practically effective. You're building based on actual needs rather than theoretical requirements. As you build, document what works and what doesn't. This knowledge is valuable for future tool decisions. When you need new capability, you can evaluate options against what you've learned works for your workflow. This prevents repeated mistakes and accelerates finding the right solutions. Your tech stack is never finished. Technology evolves. Your work changes. New tools emerge. What works today might not be optimal tomorrow. This isn't a problem, it's reality. Build your stack with this in mind. Don't overinvest in permanent solutions. Favor adaptable tools that evolve or can be replaced without catastrophic workflow disruption. The ultimate goal of your tech stack is enabling you to think at the speed of your ideas rather than the speed of your tools. When your stack is well designed, you're not fighting software. You're using it naturally to translate thoughts into results. The tools fade into the background, becoming extensions of your thinking rather than obstacles to it. This is what separates professionals with thoughtfully designed tech stacks from those using whatever software they happened to install. One group is constantly frustrated by tools that don't quite work right, integrations that require manual handling, and workflows that feel clunky. The other group has systems that feel effortless because they've invested in making them work smoothly. And here's the compounding effect. A good tech stack makes you more effective, which gives you more time, which lets you invest in further stack improvements, which makes you even more effective. This virtuous cycle separates high performers from their peers over time. Not because they're inherently more capable, but because they've built infrastructure that multiplies their effectiveness daily. So if you're serious about professional success in an AI-integrated workplace, treat your tech stack as critical infrastructure worth intentional investment. Not just having tools, but having the right tools, configured well, integrated smoothly, with automation where it matters, and documented so you can maintain and improve it over time. This isn't glamorous work. It doesn't directly produce deliverables. but its foundation that makes everything else possible. Like an athlete's training routine or a chef's kitchen setup, your tech stack is what enables excellent performance consistently rather than occasionally. Build it thoughtfully. Maintain it deliberately. Let it compound over years. And watch as you accomplish in hours what others struggle with for days, simply because you've built the infrastructure that makes effectiveness natural rather than difficult. We're at the end of this exploration, and if you've stayed with me this far, you've absorbed a lot. Tasks versus jobs. Prompt engineering as structured thinking. Workflow automation. Tool mastery. System thinking. AI as junior assistant. Personal tech stacks. Each chapter addressed a specific capability that matters for professional success in an AI-integrated workplace. But here's what matters more than any individual capability: the connecting thread that makes these elements parts of a coherent strategy, rather than random skills. Because the real question isn't, should I learn prompt engineering? Or, should I master this tool? The real question is, how do I build a career that remains valuable regardless of how AI evolves? That's what we're addressing now. Not tactics for today, but strategy for decades. Not specific skills that might become obsolete, but meta capabilities that remain relevant regardless of technological change. This is about future-proofing yourself in a fundamentally uncertain environment. Start with a hard truth. Nobody knows exactly how AI will develop. Predictions range from incremental improvement to revolutionary transformation. Timeline estimates vary from years to decades. Specific impact on individual professions is debated by experts who reach opposite conclusions. Anyone claiming certainty about AI's future is either lying or deluded. This uncertainty is uncomfortable. People want clear answers. Should I learn programming? Will my job exist in 10 years? What skills are safe? These questions assume knowable futures. They don't have good answers because the future isn't knowable with precision. But uncertainty doesn't mean helplessness. You can't predict exactly what skills will matter in 2035. You can position yourself to adapt to whatever emerges. You can build capabilities that transfer across contexts, rather than betting everything on specific tools or techniques.
You can create resilience that lets you pivot as circumstances change.
This is what future-proof career strategy means. Not finding the magic skill that will always be valuable, building adaptability, learning capability, and judgment that let you continuously evolve regardless of how technology develops. Let's start with skill selection, because choosing what to learn is one of the most important decisions you make repeatedly throughout your career. Most people approach this reactively. They learn what their current job requires or what seems hot right now. This creates vulnerability because jobs change and trends fade. Strategic skill selection asks different questions. What capabilities are valuable across multiple contexts? What skills compound over time rather than becoming obsolete? What knowledge transfers to adjacent domains? What expertise builds on timeless principles rather than transient tools? Apply these filters to any skill you're considering learning. A specific software version? Narrow applicability, likely obsolescence. The underlying principles that software implements? Broad applicability, unlikely obsolescence. A trendy technique everyone's talking about? Possibly valuable, possibly fad. The fundamental capability that technique is one approach to? definitely valuable if the underlying need is real. This means favoring foundational knowledge over surface skills. Learn systems thinking, not just how to use specific systems. Learn communication principles, not just how to use current communication platforms. Learn analysis methodology, not just how to use particular analysis tools. The foundations transfer, the implementations change. But don't take this too far into abstraction. Pure theory without practical capability isn't valuable either. The sweet spot is grounded fundamentals, principles you understand deeply and can apply practically across contexts. This is why we spend a chapter on mastering one tool deeply. The tool itself might change, but the mastery mindset and deep learning capability transfer to new tools. Consider durability when evaluating skills. Some capabilities have been valuable for decades and likely will remain so. Clear writing, logical thinking, numerical literacy, ability to collaborate effectively, judgment under uncertainty. These aren't trendy, but they're enduringly valuable because they address permanent aspects of professional work. Other capabilities are emerging as newly important. Prompt engineering didn't exist 5 years ago, but will it matter in 10 years? Maybe AI interaction evolves beyond text prompting. Maybe it becomes so good that anyone can do it without skill. Or maybe it becomes more important and specialized. You can't know for certain, which means investing heavily in it alone is risky. But learning it as part of broader human-AI collaboration capability is sensible. This suggests a portfolio approach to skill development. Have deep expertise in something enduring. Have working knowledge of current tools and techniques. Have learning capability that lets you adapt to emerging needs. Don't bet everything on any single skill or domain. Diversify in ways that create mutually reinforcing capabilities rather than scattered knowledge. Think about transferability. Skills that apply in multiple contexts provide optionality. If you're excellent at X and X becomes less valuable, you're vulnerable. If you're excellent at X, which applies in contexts A, B, and C, you have options. This is why we emphasized systems thinking. It applies everywhere. Why we discussed workflow optimization, valuable in any domain. Why we covered problem solving with AI, relevant across professions. Avoid dead-end specializations. Some career paths are very specific to current technology or market conditions and don't transfer well if those conditions change. Others build capabilities that apply broadly, even if your specific job changes. When choosing specialization, consider, if this specific role disappeared, what would my capabilities enable me to do instead? This isn't about avoiding specialization. Depth matters. But choose specializations that build transferable expertise, not just narrow technical knowledge tied to specific implementations that might become obsolete. Now let's talk about learning capability itself. Because in an environment of constant change, your ability to learn effectively is perhaps your most important meta skill. You will need to learn new tools, new techniques, new domains repeatedly throughout your career. How quickly and effectively you can do this determines how successfully you adapt. Effective learning isn't just consuming information, it's building usable capability. You can read 100 articles about a topic and still not be able to apply it effectively. Real learning means developing mental models, practicing application, receiving feedback, and integrating knowledge into existing understanding. This means favoring learning approaches that create genuine capability over those that create familiarity. Doing projects beats watching tutorials. Teaching others beats passive study. Applying concepts in your real work beats studying them abstractly. When learning anything, prioritize application and practice over passive consumption. Build learning systems that make continuous education natural rather than requiring constant willpower. Follow experts in your field. Dedicate time weekly to learning. Experiment with new techniques in low-stakes contexts. Teach what you learn to solidify understanding. These habits compound over years, creating massive knowledge advantages. Stay adjacent to your primary expertise. Learn things that connect to what you already know, rather than being completely random. This creates knowledge networks where new learning connects to existing understanding, making both more valuable.
A marketer learning data analysis makes both skills more valuable together. A developer learning user experience principles becomes more effective at both. But also maintain intellectual curiosity beyond immediate professional needs. Read broadly. Explore tangentially related fields. Understand context beyond your narrow specialty. This provides perspective that makes you more effective in your primary domain and creates unexpected connection opportunities. Now, adaptability. In uncertain environments, the ability to pivot quickly is enormously valuable. Some people get comfortable in specific roles and become rigid. When circumstances change, they're unable to adapt effectively. Others remain flexible, seeing career evolution as natural rather than threatening. Cultivate adaptability deliberately. Take projects outside your comfort zone occasionally. Learn skills adjacent to your primary expertise. Build diverse professional networks. Maintain awareness of how your industry is evolving. These practices keep you flexible rather than letting you calcify into narrow specialization. This doesn't mean changing direction constantly. Depth matters. But depth combined with adaptability is more powerful than either alone. You have deep expertise in your primary domain and capability to evolve as needs change. Professional networks deserve emphasis because they're often more valuable than individual capabilities. Strong networks provide opportunity awareness, learning resources, collaboration possibilities, and resilience during transitions. Invest in professional relationships deliberately, not just transactionally. This means helping others without immediate return expectation, sharing knowledge generously, staying connected with former colleagues, and participating in professional communities. Over years, these investments create social capital that generates opportunities impossible to create through individual effort alone.
Let's address the elephant in the room. AI might change everything. Not just improving tools or automating tasks, but fundamentally restructuring how professional work happens. Maybe. We don't know. How do you prepare for that level of uncertainty? By building capability that remains valuable across scenarios. In a scenario where AI handles most routine professional work, what's left for humans? Strategy, judgment, relationship work, creative direction, ethical oversight, managing AI systems. Position yourself for these higher-level roles rather than clinging to task execution. In a scenario where AI augments humans dramatically but doesn't replace them, what matters? Ability to collaborate with AI effectively, understanding of AI capabilities and limitations, judgment about when to trust AI and when to override it, system design skills that integrate AI appropriately. We've covered all of this. In a scenario where AI progress is slower than hyped and professional work changes incrementally, what matters? Deep domain expertise, effective use of available tools, productivity optimization, continuous skill development. Traditional career success factors, essentially. Notice the overlap? Core capabilities that matter across scenarios: judgment, adaptability, learning ability, collaboration skills, system thinking, and deep expertise in something valuable. These aren't AI specific. They're professionally valuable regardless of how AI develops. This suggests a specific strategic approach. Build those transferable capabilities while remaining aware of AI developments without obsessing over them. Don't ignore AI. We've spent this entire exploration discussing effective AI integration. But don't assume AI determines everything either. Stay informed, stay adaptable. Stay focused on building genuine capability. One specific recommendation: maintain hands-on capability. As AI handles more execution work, there's temptation to stop doing things yourself and just direct AI.
Resist this entirely. Maintain ability to execute yourself, even if you usually use AI assistance. This preserves your judgment about quality, keeps your skills sharp, and provides fallback capability when AI isn't appropriate or available. Think of AI as a productivity multiplier, not a replacement for capability. A 2x productivity multiplier is incredibly valuable if you're highly capable. It's much less valuable if you're barely functional to begin with. 0 multiplied by anything is still 0. Focus on being genuinely excellent at what you do. Then use AI to multiply that excellence. This brings us to the tension between specialization and generalization. Specialists command premium rates, but risk obsolescence if their specialty becomes less relevant. Generalists have more adaptability, but less market differentiation. What's the right balance? The answer isn't universal, but a pattern works well. Be T-shaped. Deep expertise in one area, the vertical of the T, with broad competency across related areas, the horizontal. This provides both market differentiation and adaptability. You're hireable for your deep expertise, but adaptable because of your broader knowledge. As AI evolves, adjust your T. Maybe your deep expertise needs to evolve with technological change. Maybe your broad competencies should expand into adjacent domains. The shape itself, depth plus breadth, remains strategically sound even as specific knowledge areas shift. Let's talk about continuous value creation, because career success isn't about reaching a stable position and staying there. It's about continuously creating value in ways that justify your compensation and security. In an environment where AI is handling more routine work, what does value creation look like? It means solving problems that don't have template solutions. It means improving systems that others accept as adequate. It means identifying opportunities that others miss.
It means making decisions that require judgment under uncertainty.
It means building relationships that create mutual value. It means developing innovations that advance your field. These value creation modes are resistant to AI automation because they require contextual understanding, creative insight, and judgment that AI currently lacks. Position yourself to do this work rather than routine execution, and your value remains robust. This positioning requires proactive career management. Don't just do what's asked. Look for opportunities to create value beyond job requirements. Propose improvements. Take on challenges. Build things that don't exist yet. This establishes you as someone who creates value, not just someone who completes assigned tasks. Document your impact. Most people are terrible at articulating their professional value. They can describe what they do, but not the impact it creates. Learn to translate your work into business outcomes, efficiency improvements, revenue impact, cost savings, quality improvements, whatever metrics matter in your context. This isn't about taking credit inappropriately. It's about making your value visible, rather than assuming others will recognize it automatically. Build professional reputation deliberately. Reputation is capital that compounds over time. It creates opportunities, commands premium rates, and provides security during uncertain times. Build reputation through excellent work, knowledge sharing, problem solving, and reliability. Protect it carefully because it's difficult to recover once damaged. Now let's address career transitions, because few people stay in exactly one role throughout their careers. You'll likely change jobs, change roles, maybe change fields entirely. How do you navigate transitions successfully? First, recognize that transitions are normal, not failure. Career paths aren't linear. Evolution is expected. Don't cling to roles or identities that no longer serve you just because change is uncomfortable. Second, plan transitions rather than reacting to them. If you see your current role becoming less relevant, start positioning for adjacent roles before you're forced out. If you want to move into different work, start building relevant capabilities while you're still employed and stable. Proactive transitions are less stressful and more successful than reactive ones. Third, leverage transferable skills during transitions. Even when changing domains, you bring capabilities that apply in new contexts. Articulate these transfers clearly. You're not starting over. You're applying existing expertise differently. Fourth, build bridges before burning them. Maintain positive relationships even when leaving situations. Professional worlds are smaller than they seem. Today's employer might be tomorrow's client, collaborator, or reference. Handle transitions professionally, regardless of circumstances. Now, financial stability. Career strategy isn't just about capabilities. It's about having financial resilience that lets you make good decisions rather than desperate ones. Build emergency funds that provide runway during transitions. Avoid lifestyle inflation that creates financial fragility. Invest in skill development, even when it's not immediately necessary. This financial stability provides options. You can leave bad situations. You can take calculated risks. You can invest time in learning rather than always optimizing for immediate income. These options are enormously valuable for long-term career success. Let's address the emotional and psychological aspects of navigating uncertainty, because they matter enormously and are often ignored in career strategy discussions. Constant change is stressful. Uncertainty is uncomfortable. AI developments can feel threatening. These emotional responses are normal and valid. Develop practices that maintain psychological resilience. This might be mindfulness practices, physical exercise, social connection, hobbies unrelated to work, therapy, or whatever works for you personally. Professional success is unsustainable if you're constantly anxious, burnt out, or depressed. Mental health is career infrastructure. Build identity beyond your specific job. If your entire self-concept is, "I am a specific job title," and that job becomes less relevant, you experience identity crisis. Instead, build identity around broader capabilities. I solve complex problems. I help organizations achieve goals. I create value through analysis. This provides stability even as specific roles change. Maintain perspective. Yes, AI is changing professional work, but work has always evolved. Previous generations navigated computers, internet, mobile, and countless other changes. This is another transition, not the first or last. Humans are remarkably adaptable. You're capable of navigating this successfully. Finally, remember that AI is a tool created by humans for humans. Its development direction isn't predetermined. It's shaped by human choices.
The professional landscape isn't something that happens to you. It's something you participate in creating. Your choices matter. Your voice matters. Your career is something you build, not something that happens to you. So here's your future-proof career strategy in summary. Build deep expertise in something valuable. Develop broad competency across related areas. Master core capabilities that transfer across contexts. Stay adaptable and maintain learning capacity. Use AI as a productivity multiplier, not a replacement for capability. Build financial resilience that provides options. Maintain psychological health through change. Create value continuously rather than resting on past accomplishments. Build professional networks and reputation deliberately. Navigate transitions proactively rather than reactively. This isn't a guarantee. No strategy guarantees specific outcomes in uncertain environments. But this approach creates resilience, adaptability, and continuous value creation that position you well regardless of how AI specifically develops. You're not betting on one future. You're preparing for multiple possible futures while building capability that matters across scenarios. The professionals who will thrive aren't those who predict the future correctly. They're those who build capability to navigate whatever emerges. They're those who see AI as one factor in an evolving professional landscape rather than the only factor. They're those who invest in themselves continuously rather than hoping their current skills remain sufficient forever. And if you found value in this exploration, if these ideas have changed how you think about your career, your skills, your relationship with AI, then do two things. First, subscribe to this channel, because we're building a community of professionals who aren't just adapting to AI, but strategically positioning themselves to thrive because of it, who understand that the future belongs not to those who resist change or those who blindly accept it, but to those who navigate it intelligently with eyes open. Second, hit that like button. Not because I'm begging for engagement, but because that signal helps more professionals find this content. Every like tells the algorithm that this matters, that this conversation is valuable, that more people need to understand these principles. And honestly, more people do need to understand this, because the gap between professionals who get this and those who don't is widening every day. The earlier people understand these dynamics, the better positioned they'll be. The future of professional work is being written right now. Not by AI alone, but by how we choose to integrate AI into our work. Not by technology alone, but by the strategic choices we make about capability development. Not by market forces alone, but by the communities we build and the knowledge we share. You're part of writing that future. Your choices about what to learn, how to work, what to value, these aggregate across millions of professionals into the collective future we all inhabit. Choose wisely. Build capability deliberately. Stay adaptable. Create value continuously. And remember that you're not just navigating change, you're participating in creating it. The age of AI integration isn't something happening to professionals. It's something we're building together, each through our individual choices about how to develop our capabilities and integrate new tools. Make those choices strategic rather than reactive. Make them thoughtful rather than panicked. Make them yours rather than following what everyone else does. Because at the end of the day, your career is yours to build. The tools change. The techniques evolve, the market shifts, but your capability to learn, adapt, create value, and navigate complexity, that's yours to develop. And in an uncertain future, that's the most valuable thing you can build. Thank you for staying with me through this entire exploration. Now go build something
remarkable.